We can talk more about that. But.
I would say.
Yeah.
You wanted me to choose the elder unfortunately.
Which,
I had a little trouble finding.
Right.
People really, they're really knuckling down on one.
Well, this is the interesting thing too. I think.
We're in a.
Oh yeah. Okay. Let's talk.
Okay, yes, yeah. Thank you.
Oh.
And folks online, you're okay?
Yes, we can.
Yeah, sounds good.
Okay, well, welcome everybody to the 2026 winter meeting for the Software Engineering Working Group. Legion and I are happy that you all. But I'll start with the usual CGA and CAR code of conduct. We use this flower a lot, and I just wanted to highlight two of the petals that I thought were going to be useful for today. So the offer constructive feedback, like you don't have to agree with everything everybody says, but just agree nicely. And I think given the hackathon, like share the error is an important one. There's these groups of people working together, like make sure everybody has a chance to contribute. It feels like they're participating. So I guess you've probably seen this on the website, but the big picture agenda for the next 2 days, we're in this 9 o'clock, like this half hour general welcome and project pitch time. Then this morning, there'll be a discussion on AI assistance in this room. And if you're not interested in hearing about people using AI assistance, you're welcome to work on a hackathon project, either in the outer gaming room or in the library. And there's like a secret passage to the library through the kitchen where you can go around the hallway. But there's a break at 10:30. And then there'll be coffee and snacks and stuff out in the outer gaming room, like there are right now. And then we'll have an hour and a half for lunch. In the afternoon, there'll be a discussion on running Fortran and C code on GPUs in this room. And again, if you're not interested, you're welcome to work on hackathon projects in the library or the outer gaming room. But the meeting we're going to try to adjourn at 4 o'clock, and there'll be a happy hour at the Southern Sun, which is down at the bottom of the hill, the corner of Broadway and Table Mesa. It's a cash-only pub, but they have an ATM on site with like a $1 ATM fee. Tomorrow is entirely hack time. So show up here sometime after 8:30, but find your group. You can spread out across this room, the outer gaming room, the library. You can take breaks kind of on your own schedule. We'll reconvene in this room at 3 o'clock to get a rundown on what everybody accomplished during the hack time. Zooming in on today, so we have, I think, 6 talks spread out over this morning from people at NCAR, people from outside NCAR, talking about their experiences with AI assistance. We'll have about 25 minutes for discussion at the end. And again, we have, I think, 6 talks in the GPU session. We'll have 20 minutes for discussion at the end. Just some of the general boilerplate, what's been happening since the June workshop. So we have the CSM summer workshop coming up this June. Again, it's June 15th through 17th. I believe it'll be at Center Green, like it has been for the last bunch of years. The CSM tutorial is the week of July 6th, and that'll be here. The CSM3 timeline is a little bit fuzzy. We're still finalizing the configuration for the PI control run, and I think the expectation is to have the spin-ups the spin-up run for CMIP going soon, and that's going to be a long process. And the hope is that we can actually start the CMIP runs before the June workshop and start sharing some of the initial preliminary output. The actual release date is uncertain, but it'll probably be in the summer after the workshop. And then everybody in this room knows this, but that NCAR has been in the news a ton over the last few months, as evidenced by the fact that we're in this room right now. We're just doing this kind of day by day business as usual, but we're told not to. So thanks for coming. Thanks for being here. Thanks for trusting this event was actually going to happen. Is Mari here? Maybe we will come back to these slides. So Mari wanted to talk about goes across working group session at the CSM workshop. And we'll come back to these slides when she's here to do that. So I think, Leisha, if you want to give
Okay.
the NOAA updates.
Yeah. Yeah, hi, good morning, everybody. So my name is Leisha Bernardet. I work here in Boulder at the NOAA Global Systems Laboratory. So I do not work directly with CSM, but it is great pleasure and also great fun to participate in this group. And I really enjoy coming to the working group meetings. So within NOAA, we work with a variety of models, but we mostly work with what we call Unified Forecast System. And that's an Earth system model. It's also community-based, community developed and used by the community. And a few things to point out here in this slide is that we are using this UFS system to work with a number of different applications. So we work on both global scales, but also going down to more local scales, using this forecast system from hourly to subseasonal prediction. So I think this has a lot of parallels with initiatives that are going on here at NCAR. We aim to use configurable infrastructure here, and of course, the goal of all these forecast systems to provide actionable information for decision makers, be it them the National Weather Service or other partners in industry, academia, and other aspects. So it's amazing to look at how many components and subcomponents are shared between the Unified Forecast System used by NOAA and CSM. So for example, in terms of dynamical cores, UFS has the FE3 dynamical core, which CSM also has, and we are now incorporating MPAS DICORE, which you guys already have. We run with the CCPP for community, for physical parameterizations, and I think you guys are putting CCPP next versions of your model. We're both using MOM6, size 6 for ICE, WaveWatch 3. We use aspects of the community land model, specifically the lake part of it. And we're also sharing components as far as Musica that is going in both CSM, but also into the UFS. Finally, we share the coupling infrastructure for all this based on the SMF with both the CMAPS mediator and the CDEPS data components. So a lot of synergies, both in the science and applications, but also in the components. Just a few highlights of what we have been to in 2025. This year, we transitioned a new hurricane application to operations at the HEFS that goes down to 2 kilometers over nests in the different hurricane basins. We have the rapid refresh forecast system that's going to be operational later this year. It's 3 kilometers over the entire North America for weather and smoke forecast. We're pushing this to the community inside the short-range weather application. We have an air quality capability that's also being released this year to operations that's coupled with the EPA CMAQ for chemistry. We have a GCAFS, gas chemistry and aerosol forecast system version 1 going to operations later this year that's coupled with NASA GoClark aerosols for aerosol prediction. We have an upcoming version of the GFS, Global Forecast System, that will be the first fully coupled GFS. Up until now, GFS is atmosphere only. Going forward, after this upcoming implementation, it's fully coupled model. And we have a seasonal forecast system coming up and more things. And we're moving on to the cloud, apparently. So. And if you were at the recent American Meteorological Society meeting, that was in Houston, Texas. You saw the announcement from NOAA and in particular the National Weather Service of their new Moonshot GOA, that's how it's being referred to, which is running in operations a global MPAS coupled ensemble. So this is a big deal, and it's up to us to now let NOAA make this model actually produce. So I see it's very beneficial for me and our other NOAA colleagues to be in contact with your community because you're such experts in Earth system prediction systems. So, and I wanted to say, I think these moments are very productive. So last year we had all these hackathons, right? One of the hackathons was in putting the PUMA's microphysics into CCPP and connecting with the host models. We had folks, Jesse and Dustin, myself were the organizers. And last week I went to the first science talk, real science talk of PUMA's running the unified forecast system was given by PSL, NOAA PSL colleagues here in Boulder. Wow, that's amazing. So that's something that we created. So with that, thank you. And I'll pass it back here to Frank.
Okay, so we're going to spend just a little bit of time talking about the available hackathon projects. This is where things get a little bit clunky because we don't have like a great way to have you guys break into groups and figure things out. And with the talks coming up, there might be some people wanting to hack, other people wanting to talk. But I feel like this is a room full of very bright people. We can figure this out. The 5 projects we have, there's some general Cupid development that I'll talk about. There's running Cupid and multi-instance CSM for ensemble runs that Molly will talk about. Sam is organizing stuff on unit testing in Fortran and Python. And John's going to organize something on using Amrex to modernize MOM 6, and I think it might also be unit test heavy. And then I think it's going to be Brian who's going to talk about using an AI assistant. But this last one kind of came together at the last minute, but I'm sure it'll be a lot of fun. For people online, I dropped links to all of these Google Meets and I pinned it. So hopefully that means that people who join later than I did can still see it. If you can't see the links in the chat, let me know and I'll copy and paste them again. Yeah, so project organizers, as we're going through and working on these, make sure the Meet is open on at least one of the laptops so that people do drop in virtually. Like there's somebody to receive them and they can participate. And maybe also talk about your availability for today. Like, are you going to be in both talk sessions and one talk session? You're going to be working on your tech stuff all day. So with that, I'll just say that for the general Cupid development, there's a huge backlog in the Cupid issues page on GitHub. We have a hackathon appropriate. We have a tag for issues that we think would be good to tackle in a hackathon, and that's linked here. There are a bunch of issues that should be quick to tackle. We just need people to do it. And really, we'll welcome help on any of the issues that I've listed, a few specific ones, just in case this sounds like fun for anybody. I'm going to be in both the AI talks and the GPU talks, and so I'll mostly be available to work on this tomorrow. But you guys are welcome to start this without me. Molly, do you want to?
Yeah, sure. Yeah, hi everybody. I'm new to this group, so thank you for having me, and thank you to Mike for encouraging me to kind of bring this up. I'm an ASP postdoc here, and I spend a lot of time with the data assimilation group. So this project comes out of some of the needs we've encountered in map setting, which is that DA, particularly when run through Dart with CSM, produces lots of history files, and those fill up our storage spaces really quickly. And with CSM2, we had this kind of process by which we would use the old time series tool to very quickly produce time series history files that reduced the storage overhead. I've tried to use Cupid to do that with the multi-instance application in CSM2 so far, and I've had some trouble with it. So the idea with this project is that we would expand Cupid's ability in its time series tool to play nice, basically, with the multi-instance history files. So it should be a pretty straightforward project and pretty low demand. I'm not going to be available to work on it today, but I will be spending all of tomorrow on it if anybody wants to come hang out. And I think it has some potential lift-off points for broader applications for ensemble simulations outside just DA. But that's the pitch.
Glad I remembered the order correctly.
Yeah.
Hi, I'm Sam Raven. I'm a software engineer here in CGD, the terrestrial sciences section. I write a lot of unit tests because I do not trust myself. Do you trust yourself to write unit tests? Well, sorry, I can't do any more than that. But basically, I don't like to work on code unless it's already being tested. And so in this hackathon, I'm planning to very briefly introduce two different unit test frameworks. So there's unit tests like PyTest for Python code, and so that's testing your own Python code. Then there's also PF unit, which we use in CTSM and I think elsewhere in CESM to test our Fortran code. This is not a tutorial. Sometimes people say we're doing a hackathon and it's actually a tutorial. I will link to tutorials. I will tell you some of my favorite features of these systems, but we're going to move very quickly into you actually learning independently / with any experts who decide to attend as well. And so it's a really good environment for self-guided learning, but having someone there with you to help you with any questions during that process. The goals. So I would like both people who have no experience to attend, as well as please other people who have experience, because I'm still kind of a beginner here, especially when it comes to PF unit. And so I want beginners to attend so they can learn, experts to attend so they can share their knowledge, as well as just have some dedicated time to write tests, because so often it's hard to make that time during our projects. What else? Yeah, the goal is for beginners to add at least one test and open a PR to their project, bringing that test in. For experts to share their knowledge and to learn something new from someone else who's attending. I will be there for the first hour in the afternoon, so I'll give my sort of brief intro there today, and then tomorrow I'll be there all day. So I'll give the presentation again in case anybody wasn't able to attend. But yeah, this afternoon only the first hour because I have other things happening. Thanks.
Done.
Wow, this is really small. So this is going to be a Turbo project hackathon. So in Turbo, we're looking at using an Amrex, a C++ productivity framework to create an alternative to FMS, and this will involve a lot of unit test creation. So this is, I'm not Tom Sawyer trying to convince you to paint a fence. Really. But we're going to be writing a number of PF unit tests and so if you want to play with PF unit, this is a great opportunity there. Rather than Fortran, if you want to play with the C++ productivity framework, that's also available if you are interested. And 53. We only have 53 pieces of the fence to make.
So I'll suggest that maybe Sam's group and John's group can sit very close together in the library. It seems like there's a lot of overlap. Brian, do you have
Yeah, so this is less of a specifically defined project and more of just an open invite to, we have an API key. And in fact, this morning, Anthropic just sent me $5,000 more that we can use to enable everybody to play with these AI agents on any of these projects. If you, for whatever reason, don't like all of the awesome projects that were just talked about, apply it to your own code. It's really just a chance to get started, get some familiarity, learn. And if you have questions, talk to people who played with them a bit more already. Everyone uses AI agents differently, so there's no predefined, you're going to do this and this and this. If you're doing tests, it's great for that. If you're asking about performance, that's how I often use it. So it's just an opportunity to learn and explore, really, as opposed to do something specific. So yeah, thank you.
So those are the 5 projects. Back up to the to Mari's storytelling slides.
Yeah, sorry, my kids took their time to get dropped off at school. Otherwise, I would have been content. Thanks for sparing me a couple of minutes. I wanted to introduce the idea of possibly having a group session, a cross-working group session at the CESM summer workshop. We've been marketing this heavily to influence Dave. Thank you. We want to have a session on storytelling as a way to explore community tools and to kind of communicate the value and the worth of CESM as well as the value of our science. And as you know, backing right up, stories are one of those things that we have been using since time immemorial. Where to go hunting, you know, what dangers to face, right through to today as a way of communicating. But the way that we communicate science has evolved such that it's very much communication with our peers rather than broader community. And so there's obviously, there are lessons that we can learn, there are things that we can do differently, and storytelling means different things to different people. It might be a case of identifying metrics that you can just output and give to somebody else to then spread the news about what your science says. It might actually be working interactively with communities. It might be working with science fiction writers. I don't know. It's all of the above. We want to move beyond the idea of scientific storylines. You might have heard of Shepherd et al. That they've looked at scientific storylines in terms of if we look at this event that happened, some massive flood or drought or other extreme event in the current day, what would it look like in the future if we really ran our models, if we looked at it in a different way? But that's just one very narrow approach to storylines, and we think that there's much more out there. We haven't a predefined idea about the session right now, so we're kind of welcoming input from the community. Is this something where we have a panel and lots of people communicate? Is this a working group where lots of people present different ideas and we come up with something all together? Or, you know, we're looking for your input. So it's yes, I'm putting this together with Laura Landrum, Diamond's chair, and James Dunn, and also Melissa Moulton has recently joined us, and I forgot to add her to the slide. Apologies. And yeah, we look forward to seeing you.
Thanks. Okay, so we have about 5 minutes before the schedule is telling us to start the AI talks. So I think we should take that time to kind of figure out if you're going to be working on a hackathon project, like find the people you want to work with, maybe the group chair, the people who presented the projects can kind of spread out and figure out where we'll be and what we'll be doing. And then we'll reconvene in here at 9:30 to the AI talk, where you're welcome to go off work on your stuff. If you're not coming to the AI talks, I'll just remind you now that the GPU talks will start at 1:15. So lunch is an hour and a half, 1:45 to 1:15. Cool. I will follow my own advice and set the outer teach. If you want to talk, you're welcome to follow. Yes. Yeah.
I'll be on the couch.
I will send instructions. All you do is move around variables.
Just a question, if we want to do like more than one hackathon, how do we?
There are different ways.
Just wander around? Okay, all right, I can wander.
Your left hand on.
Yeah. People sit right here.
You're gonna do a hackathon tomorrow? I have so much free morning, but I was wondering, like, you guys come in, you can have that one, like,
Trying to say.
good. You know, I'd be just looking at like, oh, you want to like this?
No,
I use Quadcode.
Yeah.
Make the sound good.
Yeah. That's easy. Well, it's not super easy, but like.
I don't know how to use it.
So.
Yeah. Sit back on. Yeah.
The challenge is it's not an SE.
Brian provided instructions.
It's short.
You don't have something written in AMRX.
Well, and I
Try to profile it, something I can tell
We
you,
have,
oh, here's what's going on.
we have one
really
very small piece.
Very effective.
We have one non-trivial.
I think
And
that's the key, right?
Sure. This is the purpose of it, so.
I think that's
Cool.
the,
Yeah, yeah.
it's like what's generative.
So, yeah.
So I think,
Yeah.
but yeah, I think I probably won't.
Yeah, I didn't.
I don't know what we're supposed to do.
Honestly, I didn't anticipate the time.
No one else is doing it. It's like,
Yeah, that's fine. And like, so I was
kind of
thinking
like,
like, take something that like,
anyway.
you want like.
Oh, really?
You work with,
No.
Oh, that's right.
Yeah, yeah, yeah.
I said it was now. I just-
And we're all still learning.
So I mean, yeah, I totally agree, but yeah. We're both pretty there. That's why it's like, I can't like, but I gotta.
We're in the process of.
It's probably fine. I mean,
I'm assuming I'm gonna leech on to whatever you're organizing.
Yeah, well,
What are you thinking schedule wise and all that?
so we have a,
Yeah, because I see you in both sessions,
So she thinks that he's just.
yeah.
Right, and like, but technically, there's like, I guess. There's certain. Yeah, exactly. There's like a hard stop, I can't remember what it is, like second grade or something, they have to do certain things by second grade. It's kind of like. Yeah, like. So, but yeah, I think that's. Yeah. Adults are trying to do anything, you know, like, if it's sheltered in there. Again, like, I don't think that happens by meeting. Not psychology.
So we're learning this.
Education experts.
Right.
So it's, yeah. I don't know, yeah, anyways, I was like, oh, I probably should go
The
back.
process.
Yes, yeah. See my kid, yeah.
I remember, you know, mine wasn't, well, it was a situation, but, you know, I had this, and so they pulled me out of classes. Talking about a cadet.
Yeah.
But I still remember that, and that was probably.
Oh, okay. Oh, so your kids made it. So.
Might only be a short.
Yeah, so again, like, I'm trying to be like, I'm probably fine.
Oh, yeah, I'm sure it is.
But, yeah,
I'm sure it
just
is.
like.
Just get more resources.
Yeah.
All chances not, I don't want to help them.
Right.
So, yeah.
I'm gonna ask John.
Well, and you mentioned one of those.
Yeah.
We've been using it for months.
Well, they do real different, like, 'cause, I mean, when I was growing up, like, yeah, kids were held back all the time. I think they-
Oh, yeah, well, yeah, they make them repeat it very.
Yeah.
Whoa, I was just.
Sure, because SEs are awesome.
Yeah.
No, I think a lot of the high level, like, so, actually, it's interesting. So Sam is a curmudgeon about, accuracy with AI, so we'll probably talk a little bit about where it's going, where it's bad. David is more open GPT translation, that might not be. John is general chat GPT use. Maybe the ones that would be most interesting to you are the ones that are great. So Ainulalu is one that's especially, I guess I'm working with the Argentines group, and they're converting CTSM to Python JAX with, so converting code. So it's a whole model, and Kate is talking about some chemistry stuff. That said, you're more interested in how AI can help you. So we have these licenses, we have these. If you want to come to the hackathon tomorrow, like I was just telling her, make your own stuff. What you're doing, whether it's making fonts, try it out, see how it goes.
Because what I do usually,
Sure. Yeah. Yeah, absolutely. Definitely. Oh, yeah.
Right.
So, and we're gonna have a CPD exchange next week too.
My thought was, I don't want to get in your way.
I want your opinion on what we're doing.
Okay.
And in this, you know, in the sense of like, that's never gonna fly.
Right, okay.
Or, you know, that's not gonna work for this particular case. And so, right.
I mean,
We should get started on.
I think it's just a matter of, can you plug in right away to the endless research that's going on.
And also,
Which is Bob, you know?
No, I understand that.
I mean, well, that's one thing, but maybe you're talking about a little more specific.
Yeah, I went through, I was looking at some more design. You know, oh, this seems reasonable, or that's never gonna fly, or this is gonna fail.
Yeah,
I've struggled with the science development, that's advancing.
Yeah.
And I've suffered that for 25 years. And so I think it's informed of some of what I wanted.
What's a little chaos? We have plenty of that.
Because it moves.
Right. I mean,
Yeah.
I remember
Yeah.
a week past,
That's what the C and N cars.
Bob had re-implemented everything in non-boost message. He basically doubled, all the major. And it was just, that's the craziness sometimes that just comes in.
Yeah.
But, that's actually, that's just one story.
Yeah.
Yeah.
I don't want to be looking away for the.
All right, guys, we're gonna get started. All right, I'm happy to say our first speaker today is Sam Raven. He's one of our very multi-talented SEs. He works on the land model and has a degree in ecology and evolutionary biology. Which means he's way smarter than I am. What I really like is he has a healthy skepticism of AI, and that's really very valued. We're scientists, we should be skeptical. Whatever he talks about, I always learn a lot, so I'm really excited to hear what he's got for us today. So thank you. Thanks, Brian.
Thanks y'all for having me and for giving me the opening slot. Hopefully I do justice setting the table right. I have a lot of strong opinions. Must be right. So here's my perspective. I mostly have used AI assistant coding for writing, for doing Python dev work, and a little while back I had it write some workflows for me. Usually I'm working in VS Code using the built-in chat feature, and I'm using Claude Sonnet 4.5 in agent mode, which lets it, you can converse with it obviously, and then it'll just write the code automatically. I'm still doing very beginner level stuff. So you can consider this a sort of good getting started guide if you're wondering, there's so many options with AI, like how do I even get started? This is a good way to get started. I'm sure we'll have other people presenting on more advanced workflows later. The nice thing about using the VS Code chat feature is that it still lets me retain complete control over any actions the LLM takes. I say other risky shell commands. Every shell command is risky. You're not giving it explicit approval every single time. And this does require it every single time. But like I said, it can write the code itself, but then you get nice little graphics saying, like, I want to keep this and do that, etc. I always review its work and commit frequently. If you're not reviewing the computer's work, you're not doing your job. There's going to be some hater throughout this. I'm still really uncomfortable with the environmental and social harms of all this, and we need to keep in mind this is artificially cheap. It's being propped up by VC money. They're expecting to get a return eventually. Just like Uber, at some point, prices are going to get cranked up. So do not get used to these prices. I was supposed to answer why Claude, why the model I chose. I have no good answer for you. I had just heard good things about Claude. In the interface, it had a list of 1,000 models to choose from. I typed in Claude and chose one that sounded right. 4.5 is, I guess, the previous version. They're on 4.6 now. Anthropic has models named after links of poems because they have compute. So there's Haiku, Sonnet, Opus, probably some others. So Sonnet is like in the middle, I think. Why not use Opus 4.6? Because I switched to Opus 4.6 and we ran out of credit on our API key within like 36 hours. So and I didn't see any significantly better results. This took longer and it's been more goodness. All right, what do I use it for? I'm really passionate about documentation, and so I use it for adding in-code documentation. I still think it's important to have a human touch with user-facing documentation, but for things like adding type or doc strings, so like documentation of what goes in and out of the function, how the function works, so to some extent comments as well. It's been really good at that. I use it for testing. I'm also passionate about testing, leading the hackathon. I've actually learned a lot about how the Python unit testing frameworks work from seeing the tests that it writes for me. And the AIs work best if the code they're working on is already tested. And so a very typical workflow for me is, all right, I have this old function. Can you please write some tests for it? I'll look at the tests, say, you know, come up with some ideas for additional tests I want to write at those, and then I'll let it actually start communicating how the code works. Then a bunch of miscellaneous stuff. It is great at regex, and I'm really bad at regex. So for complex commands, like I want to search for things inside XML comments, right? It's really good at that, and you can have it explain like how is that regex pattern structured. Debugging, at least in Python, is pretty good at that. I'll say like, why am I getting this error, and you can usually figure it out. At least for the code bases I'm working with. Like I said, there's going to be hatering sprinkled throughout here. XAI's Grok, don't ever use it. It's like most corporations are amoral. X is actively immoral. They built an illegal power plant to power its data center in Memphis. They're just moving gas turbines around and contributing to respiratory health problems there. Grok is on what used to be called Twitter, and it's generating sexual abuse imagery and harassing people. Podcaster I listened to the other day said, Grok in the science fiction sense used to mean you're a dork complimentary. Now it means you're a dork derogatory who also hates women. So don't use Grok. All right. What do I use it for? Test it. Here's an example. We have this existing test called print message. And so in the right hand here, I'll zoom in on the screenshot. On the right hand, this is my prompt. I just said, please add some unit tests, a print message to a new class in, specify this test file. And this is what it looks like. Can you see my mouse? Yeah. So on the left hand here, this is in VS Code, like I said. All this green is new stuff that it added. If it had changed any lines, there would be a red line. Just like when you're looking at it. You can see it. So it added a new test class because that's kind of how this file is structured. It adds helpful comments and everything. It printed out. There was a whole process where it was printing out what it's done and all that. And it usually prints out a summary at the end. And it also asked if it could run the tests. And it got it wrong a few times. I said, you have to use this certain conda environment. And it had trouble loading that at first. So I had to shepherd through that. But usually it gets that right the first time. I say, use the CTSM pilot conda environment to run these tests like so. And it works. So that's pretty great. And like I said, there's this option I can keep or undo. It says there are 3 changes. So like 3 blocks of changes where I can keep or undo, and I can also keep or undo at the entire change level. This is different from git committing. So I will often keep or undo several times until I have a commit's worth of changes and committed. And I don't know if I mentioned, it always asks. I think it has to ask, just because of how the VS Code is programmed before running a shell. All right, some more hatering. AI has a huge energy footprint. So this was written in May 2025, and already at that point, it was 4.4% of US electricity. That's nuts. And it's mostly dirty energy. The rapid expansion of this kind is using traditional methods like gas turbines, right? Every time you ask an AI model to do anything, that's emissions. And if you don't care about that, I don't know why. Feel free to emphasize. You are contributing to climate change when you use it. So don't use it for docstrings. Simple prompt, please add a docstring to this function. Got for nans and that's CTF. And you can see I have my prompt there, and it says, I'll help you. It reads the file to find the relevant lines, and then it adds its the doc string, and then it summarizes the table. I actually have type hinting in here, and I could have said next. Please, in the doc string about the arguments, please say what type. Sometimes it doesn't. You're always flipping a coin. You're flipping like trillions of coins every time you use one, so you never really know. You can get into a lot of trouble using these things, especially quote unquote agentic AI. This user found out that letting AIs run shell commands without having to approve them can be a problem when it does rm-rf slash. It's really sorry about that. All right, how else can it go wrong? How's it gone wrong in my usage? It likes to undo my work. Sometimes it'll, I've asked it to do something and then I accept it, and then I do some additional work, and then I ask it to do something else. It just works from its memory of what the code looked like before I made it. So then it'll write the code and my changes are gone. Don't like that. It'll often say you're absolutely right when you're absolutely wrong. It's often overeager. Sometimes I just ask a question, and it takes that as an instruction, and it starts changing code. So if I found that you really should either at least preface it and say like, don't change any code yet, and then put that at the end of your prompt too, or just put it in ask mode. OpenClaw, this is a great one. Again, letting something run shell commands without you understanding what they do. You may have heard of OpenClaw or ClawBot or Moltbot or whatever they're calling it now that they've been taught by OpenAI. This is a system where you basically install this on your computer and you just let it do anything. And you can download the skills from a marketplace. And the top downloaded skill was one for working with Twitter, and it was nothing. So don't let these things run code that you don't understand. How else does it go wrong? Again, in my usage, it'll sometimes delete tests. This is especially true if I've been working with it for a long time. It starts to forget things, right? And so it'll add tests while deleting existing tests. And this is not something you're going to notice if you're just looking at the output of the test suite, right? You need to actually look at the changes. It'll often enshrine bugs. You can see it at work during the process. And sometimes you'll see it say, oh, there's a bug in this function that I'm testing. I'll change the test so that it passes. No, no. If you don't notice it's doing that, then you're never going to notice the bug, right? So at that point, I will click the stop button and say, no, let it fail. We'll fix it later. It often, not often, but sometimes it also writes tests that don't actually say test what they say they test. So you have to go through not just to make sure that the test got deleted, but also that its tests are doing what it says they are. There's a study recently put out by some people on an Anthropic fellowship, and this was published on anthropic.com. It's been submitted for peer review, where they found that, so these were people who were using AI in the context of learning a new Python function. And AI group did worse than they had. It's a little bit of, oh my God, they admit it, because it was Anthropic funding it, but there is actually a bright side, and this matches my experience as well. You can use these tools to learn, right? You just have to make sure that you're asking questions about what it's doing. And there's some information about sort of what that looks like, but we also need to not forget that getting really lost, getting really stuck, and overcoming that is often a really important part of learning. So don't use this to grease the wheels too much. All right, I'll end with some do's and don'ts. Do use it to help you learn. Start it with small, well-tested units of code. The asterisk there is you can have the right test code. Give it well-specified, focused tasks. When you prompt it, think, here's a commit that I want to accomplish. And I'm assuming that you're all doing good commit hygiene and not a million things in commits. So size of a commit rather than the size of a paper. If you've made changes that it hasn't seen yet, tell it to reread the code first. Watch it work. Keep your finger on that stop button. Do not vibe code. This goes back to the title of the presentation. I think vibe coding is a very useful term if we keep it specific, which is just accepting changes without reviewing what's doing. Do not accept code you haven't reviewed. Don't accept code you don't understand. You are responsible for the code you make. Don't let too much work happen without a git commit, because at some point it will screw up. And it's nice to be able to just get that back to this thing. Don't let it run shell commands by itself. And don't ever, ever, ever use Grok. Also, don't use LLMs for something a deterministic program can do better. For Python code, you can use Pylink to catch syntax errors. Don't ask this to look for syntax errors. Come on. Don't use them for trivial tasks or entertainment. There are huge environmental and social costs associated with these operations. Don't just believe someone on the internet who's trying to tell you something. Dario Amodei, the CEO of Anthropic, says we're going to expand to 5 terawatts of electricity, and this is going to solve all of our problems. He's trying to sell us. Be skeptical. Don't get used to these prices. Most importantly, don't forget what you love about this job. I didn't get into this because I love reviewing code that other people would. And that's what you end up doing a lot of the time. So don't lose sight of that. If what you enjoy is solving problems, well, you're not necessarily even solving problems. You're asking someone else to solve it for you. Did you get into software engineering because you wanted to be a manager? I mean, if you did, that's fine, but like, that's not for me, and I bet it's not true for most of you. So don't forget what you love about this job. Thank you.
I'm going to hold off on questions right now just to try to keep us on pace. We have a discussion time at the end. So, but yeah, thank you very much, Sam. That was a great talk. David's coming up here now. So David is an expert on high performance computing and algorithms at NVIDIA now, I believe, right? Yeah. And they have developed a agentic AI tool to help porting GPU enablement on large legacy Fortran codes, which is something everybody in this room knows a little bit about. So let's, oh, yeah.
It's technical links.
Oh, you're joining. Do you have a link? I don't think so. Send it to you right.
Thank you. Thanks.
Question. Do you use agent files when you do it?
I don't know.
Because I wonder if agent file would help them a lot of them.
You got it. I don't think I got it.
Oh, I'm
Yeah. Because of the way I use it, I would have to keep reminding it, like, look at this agent file. And then
Yeah.
whatever. But yeah, I'm sure.
In the spirit of what you said, a lot of people get the AI to write the agent file for them.
Yeah.
But
Which is like, okay.
but the
But
advice that we've
check it.
heard from people is that you really, if you don't give Claude an agent file, it's one that it very easily goes off the rails.
Yeah. And I will say it works really well without agent files. It's just the little things, you know, like that you wouldn't think to put in an agent file, like don't delete tests. Like I guess you could put that in there. Like it's
I
annoying.
feel like you shouldn't have to tell it that.
Yeah.
I enjoy it.
Thank you.
So go over to the meeting notes. Oh, you're not, okay, there we go. Oh, all right, yeah, excellent.
Funny you can be here in person, but not on.
Yes, yes.
You might want to
Try.
or join a companion.
Yeah, quick, it is. Oh,
Keep your name, your speakers.
yeah, turn off your, or just join your companion. Yeah, gotta love. Okay, let's get out. We'll just go back in, join again, and then let's do. What present? Oh, yeah, that's a good question. I don't know. See that. Well, it's so it's already not allowed. That's what I'm doing.
I think it's your speakers, like it's your computer without putting the audio
This
from the-
microphone on?
Yeah.
Okay, all right. All right, well then we'll try this.
All right. Or it's just a cool echo, like a wrestling or sporting event.
With the jungle.
Yeah, that's right.
AI.
You. Yeah, we're working on it, Elizabeth. 1 second. Yeah, we're aware of the echo. Yeah.
Yes. I'm on mute. It's still.
Oh, turn on. No, it's your.
I know, my speaker's on mute.
No. I tell you what, the other option is if you want to just send us your presentation, I'll load it up on this one. Or you can try that.
Opinion mode would solve this.
Okay, we're good now. Yeah, yeah. Thanks. Okay, I'll see if I can do that.
Just share screen, basically, right? I have to use Google. Okay. So share.
There we go.
Okay.
Awesome. Thanks.
It's working. Does it look good?
Yeah, it looks good.
Everybody can hear me. Okay, cool. All right, well, thanks. Yeah, so I'm David Appleton. These are some of the other people that have worked on this. So probably in contrast to the previous speaker, I'm going to tell you that, you know, I think LLMs are pretty nice, pretty good, but I think a lot of things are also in common. Like you should use them for small tasks. You don't just paste your whole code in ChatGPT and then see like, oh yeah, it worked fine. You know, just take it. It's going to work. It's really not going to work like that, but that's why we made this tool. So this is our basic premise. We've been at NVIDIA, we've been using large language models to do coding using Cursor, you know, or VS Code like companion type things. And we'll say, hey, here's a section of small code. Here's 10 lines, 20 lines. Could you please reorder the loops? Could you please rewrite this from Fortran to C++? Like this little function, right? Can you please, you know, write this from C++ to add CUDA? And it'll give you, you know, basic CUDA version, not the type maybe I would write. It's maybe the first draft I would write, but not my optimized NVIDIA, like, you know, dev tech version. But it was pretty good at that. We were seeing that it works that way. And, you know, our experience has been, it does well in these small tasks. It does give you the correct kind of code, you know, you should test it. And then it does work pretty well. But then the problem is we really want to like help people, you know, in my mind, we have all these Fortran codes, huge Fortran codes from especially the DOE or legacy Fortran codes. And how do you move these million-line code bases to say C++ and CUDA or Cocos or whatever, you know, whatever you want to change to. How do you do that? We see the AI working pretty well on little snippets. How do you tackle a whole code base, right? You paste it in ChatGPT, it doesn't work, right? It can't even see that. And this was before Codex and some of those companions came out that are more agentic AI. So we can break the problem down in size and complexity, and you will not succeed if you just sort of paste really large whole files into ChatGPT. It will pretty much get wrong, and then it will not be able to correct itself, even if you keep telling it like you're a little bit wrong and try this. So we thought, hey, can we use what currently works, which we think is small snippets work well? Can we create something still useful out of that, or should we just wait for, you know, someone else like Anthropic or something to come up with a better version? So what we did is, you know, you can get LLMs to write a lot of code quickly, but it can be wrong code. And so one question though we thought was, well, should we just wait? And then it was like, well, we don't expect perfection from humans, right? Like if you have a grad student or a postdoc or whoever, like a grad student working for you, you don't expect that the code they write, they better write it perfect. And then when they try to go compile it, you know, if it doesn't compile, you fire them and say, well, you didn't write good code. You go, oh, well, okay, let's see what's wrong. And like you work on it, right? You iterate. So we should implement that kind of idea into how we use LLMs, right? Like, I mean, just like you were saying, you should test it, and then you might prompt it more. You don't just test it, fails, and go, well, no good, let's not use them, right? Like, so it's kind of the idea. So, you know, successful programmers do stuff step by step. We all kind of use the compiler to test the code we're writing. So our idea was, you know, can we make an AI agent that's wrapped around the LLM calls? that builds up something correct from the smaller correct pieces. So if you see this Lego block, it's like we think that we can do the Lego block. How do we build the whole Lego tower? And so this is kind of our assumption that the single Lego block is working and it works, right? And we've seen this sort of for ourselves in Cursor and like a small section of code. But that is key to our assumption, right? We need the small Lego block to work in order to build up the next thing. And so here's how we sort of apply AI to production code bases in this tool we're working on. One thing we know is that you have to maintain correctness. And so you should have lots of tests in your HPC code, and you require stability. But an LLM can't really measure correctness during a response. It generates what it thinks some code should be, and then it's harder to measure if it's correct, right? You could run it through some of these things, and people give them like scores, and you put OMP parallel in the wrong spot. So I'm going to give you a bad grade on that. But instead of using and looking at the generated text, we can actually use the compiler and the regression test you should already have, and the unit test you already have, to check, does it reproduce the exact same answer for the sort of snippet we're working on? So we kind of go back and forth between generating the new idea of how the code should be written to using the compilers, the debuggers, and the profilers to test correctness. So we use two kinds of inference. We use inference to generate me some new code. I want to go from Fortran to C++. And then we say, also, it failed, it didn't work, here's the output, generate some ideas on what the problem is, why it failed, and then fix yourself, right? So we're using inference sort of twice, not just generate the new code and then it fails. So we don't have a scoring metric. I mentioned that already. Basically, I don't really care if I get a 90% or an 80% a scoring metric. I care at the end of the day, even if a user helped it, how much did that user have to help? It was a little bit, and it saved you a lot of time, then it was useful. And at the end of the day, you better get 100%. It better be correct. So I don't really care about a scoring metric for each step. I care about multiple steps finally getting to the right answer. So the goal is minimize human work, but not necessarily take it to zero. Or we might be in search of perfection that we can't have. And so we don't require one-shot LLM correctness, right? So we're not saying we should fine-tune this model. We should get it better so we get one shot, like give me the right code. If we can put in an iterative repair step, then maybe we don't need one-shot correctness. We need eventual correctness from the repair step. So, this was kind of the problem of how do you apply AI to production code bases? This is one way to do it, and this is not what we do. You take this huge code, you rewrite all the original code to see, file by file, and you use LLM inference. Maybe you do this, by hand, or tell the AI to do all these things, and then you try to fix the errors, right? And it's just going to be impossible with a huge code base. It's probably possible with a, 1,000-line script or something, and that's kind of what we were used to doing. And you might even have the LLM try to fix the 1,000-line script, but you can't do this at 10,000 or million-line code bases. So what we do is, because the AI will get hopelessly lost, that's why. So we don't do that. So what we do is, instead of taking this big leap here on the left, and then trying to make these fixes, which you kind of never get to the correct result, we try to take a lot of small leaps systematically. The same way me as a human, as an NVIDIA dev tech would port a code. If you gave me code and said, please make this, put GPU kernels in here and port the code, I would not write all my kernels and all my code and then go and test it and try to figure out what's wrong. I would write a small section, and you would come back and say, it's not any faster. And I would say, well, that's the point. It's fine. Systematically increasing my scope of what I'm speeding up. So we want to do it in sections and get back to the right path as we go. So this keys on, are the small steps sufficiently small and correctable, right? Like, again, the LLM has to be doing a good job of these small steps and repairing, or else you're kind of sunk.
Small as in lines of code?
Yeah, like,
Okay.
or context, like, does it get the right answer for the small thing, right? So that's kind of the key, and that's some of the problems we're trying to fix. Of like, we have tried 100,000-line codes, and some of the how well they're working is we're not getting as good of small blocks as we thought. So we're even shrinking the granularity to like get the right answer more. So this is kind of one of the main takeaways of how our approach works. We have a Python script currently that does this, but basically the idea is you take your old working code, you make some incremental change, which would get suggested by inference. So we use that, an LLM in this step to get the change. Actually, and there's something missing here. The first step is the thing reads through your entire million-line code base and generates sort of a a summary of what it does, it generates its own kind of context summary, because it can't hold the whole million line code base in its context, but it can hold like what, it basically creates its own table of contents and summary of what your code does and understanding of the code. And it also creates a porting plan that says, okay, I'm going to port these 70 different things systematically. This is my plan for how I'm going to do it. I recognize parallelism here. So that's one useful part of our tool. Then the next useful part is, okay, then go ahead. Yeah, you review that and you say, yep, okay, proceed. And it will start making incremental changes to each step that it outlined. But those incremental steps are gonna fail. So the key is you get a suggestion, then you do verification, this verification loop on it. So you build and run tests, and you build the code. And can you build the code? Can you run your test correctly? And then if the answer is yes, then of course you sort of accept it. If the answer is no, you go back and you say, have I tried this a lot of times? If I've tried it 10 times, I should probably just, raise my hand and say, human, can you come help? But if you have only tried it 0 times or 1 time, then you'll go back and say, hey, this was the error produced by the compiler when we tried to, use the code that you generated. Is there a fix? And, it tries to fix itself up. And we've seen pretty good success in the code LLM's ability to fix themselves when you provide them the information of, hey, the compiler says there's no header found. Well, it understands kind of then, well, I guess this must be the problem. The header's missing. And so this is sort of the non-one-shot version, right? You do this verification loop, and we see that this is crucial to getting these things to work well. And we're not taking the human out of the loop. We're just trying to make the human more efficient so that hopefully they're not asked as much about some of the more trivial stuff. And then the way we do this, we really targeted like Fortran to X, Fortran to something else, which means that we think it should be Fortran to something that has a interface you can call like C. You can call C from Fortran. So then we make it, let's go to C. If we're going to go on the GPU, let's go make a host to device transfer, write your C GPU code, Cocos or CUDA or whatever, and then let's transfer from device to host back to the CPU. Let's go back into Fortran, and then the rest of the code runs on, right? This is an approach that lets you target sections at a time, not have to I want to go to C++, I got to cover my whole code, right? If you have a interface, and the same can be true for Python to other languages, anything that's sort of callable from each other, you can make a shim where it's like, let's go to that other language for a bit. Let's do the work we want to do for that little bit, and then let's go back to the main driving program. So we have this, and this gives us a way to compare as well, because we have an option, in the compiler, we put in pound defines to say, use CUDA, let's try that path. We'll take the green path here, and we'll use our shim, and we have a blue path. We can say, don't use CUDA, and go back to the original code. And then we have a way to compare, what were the answers at this point. Each of these, I'll show you in the next slide, we also create unit tests or regression tests for each of these things we port. So if it said, hey, my porting plan is I'm going to port kernel A and then kernel B, I've identified these as kernels or functions, then it will create a separate program that will just run kernel A, run kernel B. It creates all that harness. So that, to the point of we got into software engineering to do interesting stuff. I think writing boilerplate harnesses around functions is not interesting and not fun, right? So getting AI to do that kind of stuff for you is really useful. So this one cool thing about this is it's automatically creating a bunch of unit tests for each kernel you ported. And that's also what you would want to give to, say an NVIDIA expert when you say, hey, my code, this is my most important kernel. I don't want to give you all of my code because it's hard to compile. Can you just look at this one kernel and tell me how you would improve the performance? And by the way, I already have a whole harness that runs it, some fake input data that's realistic. And, so it's giving you that. And it also is giving you Git commits in each one of these. So it's automatically doing Git commits, but not with free reign. It's pointed to this as the branch you're working in. So Git commit here. So, all this is you could reverse everything. So what acceleration is basically it's a workflow for porting CPU codes to GPUs with AI. I mean, you could extend this to it doesn't have to go to GPUs. That's NVIDIA's interest, but it works to go to C++ too. Okay, or it can work from Fortran to Python if you can call Python from Fortran. There was an interface. I don't know if there is. But this is a Python command line interface. It also tries to offload as much rote work as possible, like creating all these unit tests. And the idea is to decrease your time, say 90%, but not decrease your time totally. You're not going to just click the button and say, go for it, and then leave it alone, right? So it's not magic. If you have an algorithm that's serial, it can identify parallelism. It sort of reads the code and does a pretty good job actually of identifying, like, hey, this is a loop that is all independent, but it's not going to say, hey, you should use Jacobi here instead of Gauss-Seidel, and that's better on GPUs. It's not, it's supposed to do your code, because we don't want you to port your code and change your algorithm at the same time and then have no idea whether your results are verified, right? If you have a bug in your code, we want to port your bug so that you get the exact same results. Like, that would be a disaster if we thought we should fix your bugs as we port to C++, and then you are like, why are the answers different? You say, well, this one's the right code. Well, no one's going to believe that. So it's not a fine-tuned model. It's just using off the shelf. And it's using, we find that, like I said, I'll kind of skip this part, but it's basically a command line interface. You can use subprograms of it. It's not something we've released yet. We're releasing it sometimes on limited licenses. Eventually we'll open source it, I think, but it's sort of like, if people want to try it out, we're sort of releasing proprietary NVIDIA licenses. But I just wanted to come to tell you guys about what we're working on, because it could be coming. And it's not just us, Claude has stuff like this, or Anthropic, with code. There's Codex, and there's Claude Coder, or, so there's one from OpenAI as well that are doing similar type stuff. And so this is the next level, right? People might already be asking, in the side window, can you port this function? But the next step is, okay, can we get this process like kind of automated for a whole bunch of things so you don't have to do step by step? We're seeing that there is a difference in what you use. So if we try to use small open source models to do each of the little inferencing, they don't work as well. We needed Claude Opus 4.5 or higher. You need a pretty good OpenAI model. I think it was like GPT 5 or 4 higher. But you can't just take a tiny model that's open source. They actually don't work as well, because we need that small building block to really be pretty good. It needs to be a good coder at doing the small building block. And if you have too many errors, it's hard to fix. So here's some of the results we've done so far. We basically wrote an advection diffusion example and then said, okay, we've written this example. Now when we wrote it in Fortran and we said, can you port this example? It can do that. We ported it in all these different languages: CUDA-C, Cocos, OpenACC, OpenMP. And this is a small, line of code is like 1,000 for that. Couple functions, and it translates the functions. But it creates unit tests for all those function supports too. And then one thing that I've bolded here for this audience is Miniweather. It now ports Miniweather without any human interference of like, oh, the make file got wrong or anything. So you basically, hit the button and it changes Miniweather from, I think it's written in Fortran, but anyway, it takes a Fortran to CUDA-C with, no human intervention, and then correct results, right? Like, you could paste it in ChatGPT and get a ported code, but it's not necessarily correct. So it's working. That's about 1,000 lines, 4 functions. It's all in one file. So that's sort of one challenge that was Miniweather was, well, here's one function that's everything kind of. We've also done like Snap, the DOE benchmark, from C++ to CUDA-C. We've done some of the NAS parallel benchmarks, which are Fortran to CUDA-C. We've done some industry codes. I can't tell you what they are, but we've gone from Fortran to OpenACC and OpenMP in sections of their code. And that one, let's see if I have it here. Yeah. So the industry code was like 50 milliseconds was done by an NVIDIA principal engineer when they ported to OpenACC, and the AI agentic tool Acceleragent was 52 milliseconds spent in the kernel time. Yeah, John?
Could we go back to the last slide? There's a lot of code bloat there.
Code bloat? Yes. Well,
Could
you
you-
can make unit tests for all of them too.
Okay.
I mean, they're in separate folders. So maybe we should separate that out and
Because-
have it give you a delta of like, and this is the amount that's unit test or something.
Because one was a
there's
tip-
they're trying whole harnesses and create, stuff to run each of these unit tests. And these basically have no unit tests to start with. And then we're saying, here's a whole folder of A, B, C, D.
Yeah, it might be useful to give that number
Yeah.
without the unit test, because otherwise it looks like you're just creating 5 times the problem for.
You're right. Well, okay, that's fair, but there's also 2 points, right? Which is that, like I said, we have this pound define, use CUDA or go back to the old way. So you can switch back and forth. And now that's creating, I mean, essentially you are doing that model. You're going to double your code because you're going to have a code path that's used the new code path, use C++, and you still want to have your old Fortran code path in there. So
So good comparison. You could subtract the original lines of code to, if that's how it's structured.
yeah, well, for the unit test, but you can subtract them for the other, like, yeah, I guess you can say, please pre-process with use CUDA and tell me how many lines of yeah, that would be good. Okay. Yeah.
Similarly, like, if you look at there's 4 advanced diffusion schemes, and one of them goes to OpenACC and one of them goes to OpenRP. Like, an explanation of why one of them is 11 files and why one of them is 13 would be useful. I guess, is there an analysis of why there's an extra couple files in there?
That's a good question.
I might be too in the weeds.
No, I mean, it might be in the weeds. I mean, there's different ways OpenMP, works versus OpenACC and some of the details. But yeah, okay, it's 2 different. I don't know. Yeah, I don't know.
Yeah, I guess I like that you did 5 different code changes. It's just, I'd like an analysis of what
Sure. Yeah.
where the difference is.
Well, I mean, I will say from other experiences outside of LLMs, OpenACC and OpenMP, although they look similar, they are not really under the hood exactly similar. And so there's differences in sort of what's required to write in certain ways and stuff. So they're close and they look similar, but they are a little bit different. But you go to Cocos, there's 16. So there's quite a variation in number of files that'll be created. Partly it could be just how I decided it needed to do it. I'll also have to see if maybe this OpenMP is this OpenMP. This OpenACC here might be Fortran OpenACC, and this OpenMP might be C++ OpenMP offload. I'm not sure. Ben actually did these implementations, so I'm not sure. Let's keep going. But all this is to say we worked on basically 10,000 line codes. We can ingest things that are like 300,000 lines and work on a section of them. But our current goal now that we're working on is 100,000 line code bases. We're working with LANL, and we went to a hackathon last week where we let's try with some of your Fortran 100,000 line code bases and see if we can port them. And the conclusion from that was that we need to work a little bit more on getting the small building blocks right, because we were jumping all the way from Fortran to C++ Cocos, and it was a bit of a too big of a jump. I think that we had to do too many repair steps in between, so that's assigned to me. If I have to do like 25 repair steps, I'd like to see that number. I just have some idea in my head, but it should be like 5, not 25. If it's 25, you've jumped maybe too far away from the small enough step, so we should be taking smaller steps. So we're breaking the code into smaller pieces. We were doing it at a function level, and I told Ben now we need to do it at really like a loop nest level. So how are we doing on time? I know I started kind of
We're over, but I'm being pretty flexible because I'm going to shorten the break.
Okay. I mean, I won't run through the demo. It's basically, it goes through your code, it looks at it and says, here's what I'm going to do. And then you approve it. And we're recently deciding from feedback that users want even more control. They want to see like, here's what you're going to do. And then every step of doing it, they want to like review what you're going to do. We kind of thought, well, we'll tell you what you're going to do. And then let's let the AI just run ahead and do what it's going to do. We're not giving, well, no, I guess we are giving it access to like the command line stuff, but it's very structured in what we're telling it to do. I mean, so it could go off the rails, I guess, but we haven't ever seen it be trying to do anything strange. But users, the feedback from LANL was, they want to see the code changes, and they're also providing their own sort of style guides too, which is, something you want to do as well. Like we want our Cocos written in this way, and we want the C++ to be this way. So that's about it. Basically, the only other thing to mention is, like I said, you could use Acceleragent, and this would be half of it. If you came to NVIDIA and said, hey, I want help porting my code, I want to run really well on GPUs, the first step would be let's rewrite your code on GPUs, and that would be about half the work. And then the next step would be let's make sure it's running fast, and sort of that's the first draft kind of. And, you know, it varies. Maybe that's 70% of the work, the first part, but you know, you don't just write one draft of your ported code to GPUs and then be like, I'm done. You usually have an expert come in and say, why are these sections slow? Do you need to rethink like your data layout, your data structure? Is this the right algorithm for massively parallel GPUs? And so you might still have that. This gives you that first draft of, okay, you're on the GPU, you have a bunch of single kernel, and you can hand off to an engineer to say, please optimize these important kernels for me. But it's not like a panacea. You're just gonna say, hey, AI, rewrite my code for me. It's all good, and I'm done. Same thing if you have bugs or you have bad algorithms that are serial, so it's not gonna fix any of that. But it can save you time, and it will also, there's git commits for each one of these, right? So let's say you had it's only as good as your regression test where you tell it, yes, the results are correct or not. And let's say you missed something and you realized it later, you could go back and git bisect and say, okay, actually, this is my new test that is more complete, that captures an error I was finding in the final result. Now I can go back and git bisect to where was the code still okay, where did it mess up. So we're getting git commits for all that. Yeah, and that's all I want to say.
And I'm just going to say before I introduce John, so yeah, we have a break that was originally going to be half an hour. We're about 15 minutes behind schedule now, so I'm going to shorten the break. I feel we also have a discussion period after some of these talks. I'm going to preferentially favor online questions there because those of us who are here in person can also talk at lunch, which is an hour and a half. But this is a new topic for all of us, so I want to kind of have a lot of latitude and flexibility because we're all learning, and it's good to hear these things. So yeah. Next up is John. So John, let's get that said. So John Dennis is a senior computational scientist in CISL. He's also one of the smartest people I know on performance engineering and GPU enablement. I love throwing things like that right before you get to speak. He's been playing with ChatGPT for a little bit. So I'm always interested in hearing what he says because John has been behind a lot of key things we do, such as the SC die core, the Earthworks GPUification, some PIO work. So he's pretty much involved in everything. So yeah.
Totally.
Yeah.
No pressure.
You've created an AI now, right? Yeah.
All right, so I'm gonna go old school, and this is so 9 months ago. Hide. Gotcha. Okay, so all right, so I'm using ChatGPT, the free version. I'm using it in incognito mode, so I wipe all my context because I don't want it to know what I'm doing. I also tried Copilot integrated into GitHub, and primarily, I guess, did it truncate everything wrong? Oh
Yeah, formatting.
Did you use AI for that?
I did not use AI for that. So, bummer. All right. So, have not used them to transform large code volumes, varying levels of success. Well, people can't see it.
Yeah.
So I'm going to step through this and tell you the words that should be able to see but can't. It's gone from very bad, okay, good to amazing. So depending upon the question that I'm asking. So code exploration. So this was a Copilot prompt. It was built into GitHub, and so I asked, what is this init method did? And another one was, can you commit this change? Despite having access to the GitHub repo, it made up some random shit. That was what it was doing. And so that was pretty disappointing. And also the agent refused to perform a simple trivial operation. I didn't want to do this, consistently, but, I was just like, can you commit this? And it was like, no, I can't. And so Copilot through GitHub appears to be, in my assessment, useless. So that was very bad. So bad. CSM run modifications. I asked ChatGPT, how do I activate a particular feature in CSM3? And totally confident of the answers. It gave me some things that might work in previous versions of CSM, but mainly just made stuff up that sound reasonable. And so then I would go back and ask it, is there really a nameless parameter like that? And it was like, say, no, actually it isn't. This was a complete and utter waste of time. It really should have phoned a friend. and gotten the correct answer significantly faster. And I'm guessing that it was likely suffering from insufficient training material because, of course, CSM3 doesn't exist yet officially. And so I would there be an ability to learn about that from an AI. Transplanting, okay, so we're getting better here. So transplanting chem physics. So I asked ChatGPT, I'd like to transplant a CCPP physics package into the E3SM atmosphere model in C++. How would I do that? And it actually had some ideas about that, and it told me information. And then I'd ask stuff like, what is pseudo-density field in EMAXX? Why can't I find it in CAM? And so then it talked to me about kind of all the different formulations in the two models and how they compare. And so that was actually quite useful because it gave an overview. It was sufficiently accurate to get me started, so I knew the correct questions to ask. And so it saved me time reading versus reading all the documentation. Really not, while it was not sufficient, I did learn the questions that I should ask. So that I found that useful. This is an okay experience. All right, locating memory leaks. So this was good. So I asked the ChatGPT, a large Fortran application is leaking memory. How do I locate that? And this was actually a really thorny one because multiple people had struggled with it for like 4 months and they couldn't find it. And so then how do I locate the source? Tell me more about the Linux virtual memory system. Could you create a Fortran callable function that will write out information from the prop status file system? I did this, all this, and can you help me understand the output of heap track? So again, this is kind of like a thought partner. I'm not asking it to go write me a make file. So it allowed the creation of reusable software that has been used by multiple people to identify excessive memory usage in CSM. For example, this was used for CTSM initialization issues. It also allowed the isolation of a Fortran language error in the NVHPC compiler memory. I never would have found it. But it basically, you know, it told me enough information to basically to use this. So it significantly accelerated a very challenging debugging problem. And to answer the question, this has been fixed in the NVHPC compiler, but it allowed basically to find it and then create a small reproducer. So this was, I think, the amazing kind of result. And I'm a horrible C++ programmer. I would struggle to create a correct hello world that might compile the first time I attempted. Okay, so you know, you need to have that context. I'm a Fortran programmer. So I asked it, I would like to use a formal grammar specification to parse MOM6 configuration files in C++. What do you suggest? Now, this was, and then it said, well, there's two options, Pankel or Antler. I kind of knew about Antler because it was similar to a package that I use in my PhD research. And then I asked, can you help me modify my grammar to support a particular feature of this input configuration files? And then, of course, when I got 200-line C++ error messages, it fixed those for me, and it told me. So what it did here is it allowed me to leverage my conceptual knowledge that I had from the PhD. So I understand this field. I just didn't understand how to basically turn it into C++ code that was functional. Yeah. So it did not replace a deep understanding of the task, and it would get stuck in local minimums. It would just say, I'm giving you a grammar that does not hang, and I was like, no, you haven't. And I argued about it for about 6 hours. But then I finally realized, I finally understood the problem enough from where I nudged it out of its local minimum, and then it gave me the right answer. So what this allowed me to do is it allowed to create a sophisticated templated C++ code by an incompetent C++ programmer in several days. So I was really quite impressed by that. And so that it was leveraging, you know, I had to have the theoretical underpinning to understand what a formal grammar looked like. And it did all the syntax fixing and writing the code. Just some general thoughts. I like to use the word specific because if you say, I have an MPI question, then it drones on forever about what the message passing interface is, something I've known for 20 years. So, I'll ask it a question. I have a specific question about the Fortran language standard, right? So that sets the context. And, you know, always set the context first. I have a specific question about message passing interface, you know, MPI, because it could pick up MPI and say, do you mean the German Research Institute? I was like, no. Then trust but verify the answers. You know, it was telling me that Fortran had this particular intrinsic, and I was like, I don't think so. I can't find that. And so you always have to double check it. But so I haven't used it really to create a lot of code, but just as a thought partner and a research accelerant. So, but that's like I said, nine months ago. That's old technology. Yep.
So you mentioned like CESM3, you know, couldn't answer that. Did you provide it like context of the docs or anything? Because I mean, of course you can't answer, right? If it's not on the web or whatever.
No, I did not provide it.
We don't have the docs yet.
I thought maybe you internally have the docs, right? Like, yeah, what all it can see is sort of what, like you said, what's been trained on, but not just that. It can see what it could Google or something, or what it could find. And you could also like drag a PDF. Like we've seen success with telling it, like, hey, can you tell me about this new CUDA feature? And it's like, I have no idea because it's not public. But then you drag in like, can you tell me about this new CUDA feature? Here's the documentation, and you point it to like an internal thing, and you know, if it has access, or you paste in some word, and then it actually reads the doc for you, and then knows stuff. That's
it wasn't fair because it didn't have the training material, and I didn't try to provide it.
Yeah, but I guess the point is, it's not quick to say I don't know.
Yeah,
right.
Be aware, it'll never tell you I don't know.
It's not modest. Modest is not one of its features.
Yeah.
John, have you tried any of the paid plans yet? And the reason I ask that is because there seems to be a pretty staggering gap between quality, and one of those is that the paid plans will much more energetically use agents to grab information, and they might be more willing to get the CESM docs that the I'm cheap. And so I was curious on what you can do basically without spending, but what was just burning carbon. And the first discussion pains me because I have an electric car, solar power, you know, using, and I try to ignore that aspect. Yes.
For the C++ reader of the MOM configuration, did you show it to someone who is a more experienced C++ programmer to get feedback on like, is this code a decent C++ code? I'm curious.
I think that, so basically it, no, not yet. I shared it with the group. Essentially the implementation is a one-liner. It's basically parse mom config file in file. So it's so basically what it does is it auto generates all the things that actually absorbs the configuration file.
Great. I'll have to parse that a little more, but okay, sounds good.
Good. Anything else? Otherwise, let's thank John again. And next up, we've got Mike Kavulich from who I think you started in MQ, right? But now you're at RAL.
That's right,
and working on the NOAA UFS. And Mike has done some cool work where he's looking at local LLMs versus the cloud-based LLMs. So Very excited to see this. This is highly relevant for the cost factor as well.
Is it gonna mess things up if I use companion mode?
No, I think
Okay.
companion mode is fine. Yeah.
All right, because I have some local,
Yeah, no worries. No, that sounds good. Yeah. As Mike is setting up, I know, Mike grew up in, Connecticut, as did I. I was going to ask ChatGPT about pizza, but then I thought of the first talk and I was like, that is a total wasteful thing to ask. So we have to talk about pizza in Connecticut, New York later. So,
Well, I was gonna say, you
So-
know, if you happen to have your own, MacBook that has its own,
there you go. So, okay, you can ask yours and we'll
and
find
it's
out. Yeah,
already running on solar power,
nice.
then it's free energy. Okay, so yeah, I'm gonna talk about, something kind of completely different. This is, basically just some things I've done in the past month or so, to try to see, what can happen when you don't rely on the cloud. I needed to bold this disclaimer at the bottom and just let people know that this is all my own, all on my own, not representing the institution or any of my funding agencies or anything like that. And also just putting this big disclaimer slide. These are my personal experiences. It's entirely possible that I'm doing dumb things. The LLMs, it's probable that they're doing dumb things. This last point, this was based on a guide that was sent to me by the Civil Health Desk, so I'm pretty sure this was all okay, but just make sure you're following all your local IT policies. And yeah, do your own diligence before trusting anything important to any of this.
Sorry, can you click hide on the dialog box? Oh, thanks. Oops.
Okay. So yeah, why? I have a lot of software engineer friends. I mean, we've all heard the hype, but I specifically a lot of people who I know are very good software engineers, and they are constantly talking about how ridiculously good this technology is getting. And I have a lot of projects that could benefit from this technology. I'm doing a lot of software development, workflows, debugging, testing, all the kinds of things that are really in the wheelhouse of these coding assistants. But I'm also an atmospheric scientist, and I can't escape. The first talk set me up well for this, but there are a lot of downsides to these, very large cloud-based models. And yeah, there may be a lot of reasons why you don't want to be throwing money or resources at these problems. So I have this, MacBook right here, and I'm not utilizing it. I'm barely using, 25% of its resources the majority of the time. So why not see what I can do with it? And honestly, it also just seemed like a pretty cool project to try. This all came about when I was on my way back from AMS. I was on a plane for a few hours and had time to kill with no internet. So let's see what I can do. Okay, so what is this? Again, this is a lot to take in, but this is all stuff that you can take. So Claude Code and OpenAI Codex, you may not even know what these are. These are some of the coding assistants that are available right now. They are, available for free, and they are, I believe, open source. Some of them are open source, some of them are quasi open source. It's kind of weird, but the point is they provide these APIs that allow you to not just dial into their cloud, you can dial into anything. And so Ollama is a software that takes advantage of this, and it's a free open source application. It packages these open source and or open weight models. I can maybe describe it between those two. And into containers so that they can actually communicate on this local level. It does also actually provide its own cloud integration with these open source models, but you don't have to use that. This can actually be installed completely air gapped, no reliance on the internet whatsoever. And you can even use it like ChatGPT. I threw up on here. It comes with a ChatGPT-like chat interface to interface with these local models. But everything I'm going to show is based on these command line uses of these tools, OpenAI, Codex, and Claude Code. It's easy enough to install. I installed everything. Actually, I think I installed Ollama just by dragging down the macOS application. But everything else was installed with Homebrew. It's super easy, provided you have a fairly fast internet connection for the initial startup, because you do need to get these fairly large models onto the local machine in the first place. Just kind of giving you the like Rocky Balboa, David versus Goliath picture here. What I'm up against. This is a MacBook, 3-year-old MacBook, 32 gigabytes of shared VRAM, around 23 gigabytes of those are actually available for VRAM, which is what the LLMs use. And it's completely dwarfed by these, data center machines. It's not even in the same league. Yeah, really the only thing you have going for it is this bottom line. It's free if you already have the machine, and if you have power. So what does this look like? So I gave a few examples here. In retrospect, I wish I used a larger font, but hopefully you can follow along. This was just a very simple test comparing the using Codex with the at the time latest and greatest GPT-2 5.2, and just asking you a simple question. I was getting a PR review, and somebody pointed out that this is going to fail do something weird if Python path is not actually set. I was trying to set it. I was trying to append it to the existing path. Yeah, I asked, how do I do this? Obviously, this is something I know how to do, but I wanted to see it as some test cases. And they both gave correct answers. The cloud implementation was about 3 times faster. It took about 10 seconds versus 30 seconds locally. But actually, the local one gave somewhat better results. It actually gave me 2 different one-liners versus this bigger chunk of bash that I would put in from the cloud implementation. And I don't think this is something that's been emphasized enough by the previous talks. These things are very stochastic. You could get at the exact same problem 2 different times, get completely different answers. And that is just amplified with smaller models, smaller context windows, more uncertainty. So your mileage may greatly vary, even with the exact same inputs. Okay, so now I got to go to some screen recordings because I did not want to rely on trying to do live demos or anything like that. Yes, also that. Okay, so yeah, I gave it a shot at trying to vaguely understand a decently large code base. In this case, it's a verification workflow I've been working on that it combines a whole bunch, uses a single configuration to combine a whole bunch of Met+ tasks for verifying things. And on the left, I have the cloud model, and on the right, I have the local model. And they're running simultaneously on this machine in the past. And you can see actually the one on the right is the local model, and that actually spits out an answer faster in this case. This is in real time. Later I'll speed it up because it does get a bit slower. But that's because it didn't do as much in this case. You can see Codex is actually spitting out on the left a whole bunch of things it's doing. It's exploring all these subdirectories, reading README files, reading a whole bunch of different files. And the local model, it does have some knowledge of its limitations if I'm anthropomorphizing way too much. But it won't try to do as much because it knows it can't often. So it gives a basic overview. Now you can press it to try and do more, and that's when you might start running into limitations. But yeah, these were both fairly correct and accurate summaries that it spit out. The one on the left was much closer to something I put in an actual documentation. Sorry, I keep saying one on the left. The cloud model is the one that was probably closer to finished. But the one on the right was more than sufficient if I'm just trying to understand a code base I've never seen before. And that was the prompt. Can you describe this code base? Sorry, I should have said that. And so now I've moved on to, it's been about a minute and a half, and I've decided the one on the left is still working on. Actually, it's finished now. So I moved on to a different prompt, and I'm trying to increase the unit testing. And so I said, I gave, again, the exact same prompt to both. And I told it to reference the existing unit tests in the tests directory and see what Python scripts are not covered by existing unit tests. And again, and I promise I'm not cherry picking the good results. This just happened to come out, but it can go either way. The local one actually caught more untested code than the cloud model, and took less time. But they're both mostly correct in this case, which is again not always the case, as I have to keep pointing out.
Are they the same model, the same LLM?
No.
Okay.
Okay, sorry. So I probably should have started with that. That's
I think you said it, I just couldn't remember.
I didn't emphasize it. So this is the exact, I've been using the local GBT
Okay.
OSS 20B, which is 20 billion parameters model, which is insanely small compared to these cloud models. And also, like, they have all sorts of proprietary agentic stuff going on that they don't disclose to anybody. So actually, some of these things I even mentioned are estimates, because these big companies don't release all their data. But yeah, this was both using Codex, importantly. The same version of Codex, same prompt, just hooked into different interfaces. And then, yeah, final test, I did many more tests, but I had to cut a lot of them down for time. I'll be here either virtually or in person for the hackathon if people want to discuss more tomorrow. But yeah, this was an actual problem that came up this week, and so I was like, sure, let me throw it at the local LLM. In this case, I ran out of my free week of credits, so I decided to just work locally. I had an NCDF format file that came from NCDiff, and I wanted to visualize it. I didn't have anything locally yet to visualize. And and it was Tuesday, so the ratio was down, and I didn't have NCDiff. So, and yeah, again, this is real time. It's kind of thinking through. I asked, for those who can't see, I asked, I have an NCDF format file that I'd like to visualize, called it diff.nc. Can you write a Python script to do this? And it did think for a while. I'm going to skip forward. And this was one of the things that happens. It happens less and less these days with the cloud models. This is a problem they've really attacked. But it kind of gets like I think in this case, what happened under the hood, and you can actually examine what exactly the model is doing by pressing Control-O or something like that. I think it was trying to use the wrong tool to create this file, and it hit a wall, and it was like thinking to itself. And again, I'm anthropomorphizing way more than I should, but and it was trying, and eventually it just it spat out a script that works perfectly, does exactly what I want to do, but it only did it for one variable. It kind of made this decision, yeah, that first alphabetical variable is probably the one we wanted. You can, this is again in real time. I'm just running the script. That's what it output. That's what I expected to see. But I wanted to see more variables, so I just I resumed the session. So you can either, when you're starting these coding assistants, you can either start a fresh session, or you can resume a previous session if you kept that hash, just so it keeps that context, which is important for how these LLMs function. Just skipping forward a little bit, restarted, and I asked it, can you also add an input argument to visualize the different variables to plot? And this video is 7 minutes in total. This is going to go a lot faster if you're using a cloud model, but you may get similar results in this case. And yeah, it's just going through, it's applying a patch. It'll usually ask before it patches your code, but again, that's, somebody said, you know, git commit often. And yeah, this is after less than 6 minutes, it's already made this change. I did a quick, NC dump to see what variables are available, looked at a different one. Well, I looked at the code first, and I did look at it afterwards, and I didn't see any weird red flags or anything like that. It looked similar to Quick, well, not Quick. This would take me all day to actually write my spelling. And yeah, I was just able to make that work. I passed it the argument. and then I passed it the correct argument. And then, yeah, it showed me a different variable, also kind of how I expected. All right, so those are lab demos. Let's go back to kind of boiling this down to, the pros and cons, good, bad, ugly. So this is, again, check with your local legal and technical experts before taking any of this as gospel. But one of the potential uses for this is for proprietary and or sensitive data that cannot be uploaded, cannot be analyzed by proprietary tools. Ollama is completely open source. It's on GitHub. You can fork it. You could make your own completely, Loctite version of it. But of course, you always have to be you also always have to be trusting external. These models were created by whoever they were created by. Yeah, as we said, it's a greener solution than using overpowered data centers, especially for relatively simple tasks. Like even people who are way pro cloud computing and stuff like that, they'll tell you use the small models, the less expensive models for the simpler tasks, and then only go to the big guns when you really need it. Make efficient use of your this is also a possibility for local clusters. Like you may not have a 3-year-old Packbook, but maybe you have some GPUs lying around being underutilized, and you wanted to try something like that. You may be able to use some of the larger, more capable models than I was able to use. And this also allows you to really get in the weeds if you are interested in experimenting with the models themselves. You can really customize these models adjusting all the different factors like the temperature, context windows, penalties for different repeats and stuff like that. You can actually, I just learned about this recently, but if you have a model in, I don't know how to pronounce it, GGUF format, you can just plug it in there and it'll work. It could be some model that was specially trained on your special local hardware with your own code that you wrote. Or you can start with one of the hundreds of free options that are available in Ollama's library. And yeah, you can even just go through the metadata, modify the base instructions, and play around with stuff like that. So what are the cons? I'll just keep this. Yeah, it is slow. They talk about the latency of local versus cloud, but there's no latency with internet these days. That doesn't really matter. Especially if you're at work, unless you're in FL3 specifically, on the first floor. That might be a little slow. I've shown a lot of examples where it gave good enough results, even potentially better than the cloud versions. But you're never going to get the same results. It's clearly inferior to the larger, more proprietary cloud models that have been, coded with infinite resources and provided infinite compute, especially for very intensive tasks. Obviously, you're not using as much power, but you are using a decent amount of power. When you're redlining your local machine, as I was pretty much with this, I was using pretty much the biggest model that I could get to run, using about 16 gigabytes of RAM out of my 23 usable total. Yeah, so it kills the battery very quickly. You only get like an hour and a half on the MacBook, which is very short if you know how good these batteries usually are. But you can configure stuff like that. You can configure how long the model is loaded in memory, how long it times out. I have noticed that if you are using too much RAM, for example, if you're a Google Chrome user and they decide that they need to use 15 to 20 of those gigabytes for some reason, the process will sometimes just silently fail. But you can usually reprompt it and it'll just continue as it was. The ugly. This is obviously not the highest priority of the developers of these software development tools. So things can get weird. They have this open source API where you can use whatever model you want, but they are not putting any resources into them because it doesn't make any money. Why would they? So the model support is mixed. Some models just don't work at all. This may be just because of the metadata that you haven't set up. If you properly set that up yourself. I just put an example here where I was using Claude Code, and instead of doing an answer, it just spit out a JSON query, which was obviously supposed to go to the LLM, but instead it and yeah, and Codex specifically, I just want to rant about this. They had a typo in their metadata that is overwritten from the cloud every time you open Codex. And they have a dash instead of a hyphen. So it wouldn't find the metadata. The local model was degraded. And every time I tried to change it, it got overwritten from the cloud. So I had to fiddle with some stuff to get that to work properly. But it eventually. If you have a different machine, as I mentioned, this is just my personal experiences, but you can do a lot of stuff with this. There's a lot of models out there from a lot of different provenances, and a lot of different capabilities and a lot of different sizes. The one on the left, that's the one I've been using, GPT OSS 20B. And that uses about 14 gigabytes in memory. I think I said 16 before, but it's about 14, which is really close to maxing my machine when I'm actually using other applications as well. But it's very capable. It seems like what this MacBook can do is kind of right on the cusp of usefulness. I think if you had a less memory, like 24 or even 16 gigs, I don't think you would be able to run a useful local LLM for useful tasks, at least in coding. I didn't get into anything else, but this is not just coding. There are local image generators. I play around with that a little bit. It comes with a chat interface. You can ask it questions about anything. There actually is even a web interface. It can query the web if you set that up. But again, it doesn't have to use that, and it can run completely local in air-gapped. Okay, so this is something that you should try, maybe. It's obviously not going to be the same performance. If you're interested in performance over all else, it's not going to cut it. Is there real value? I think there really is. It was able to do useful tasks, maybe a little bit more slowly than the cloud model, but way faster than I would have. And it was a fun project. It was cool. I think I learned stuff, and I'm definitely going to keep playing around with this in the future, seeing what it can do. And yeah, if it sounds like something you'll find interesting, you will find it interesting, I promise. That was all I had. Thanks.
Right on. I'm going to hold questions for now, although I'll make one comment related to this. There is a middle ground between using the Torment Nexus and your laptop, which is that Sizzle has a local Llama set up with, I think they're using GLM 32 billion parameter. And for people on the VPN, that's another option. It doesn't go to the cloud. It stays on Sizzle hardware. Kevin Herbcheck set that up on Cirrus. So if people are interested, let me know. I think ultimately we do want to explore how these all work and how versus the other ones. So we have to do a little more systematic exploration. But let's hold the discussion for later. I'm going to say let's take until 11:05 and be back here. So you get a 12-minute break rather than the original 30-minute break, just to kind of keep us on track. That'll be a 5-minute delay from Aya's talk. But yeah, thank you very much. Yeah.
Or can, you know, that's.
Well, it's interesting, it's like, it's interesting to like see how this one like changes the world of software back to like how it was decades ago, where it's like, like now it's just cheap to write your own.
Yeah,
So why go look for something that already exists, that might do like 90% of what you want, like, yeah. For better or for worse, I mean, I think there's good things about that stuff, but like, yeah.
I used to be.
I don't mind.
Yeah, it's interesting. It's disruptive.
I don't mind a very frank.
I find it.
Hey, guys, come on in. We're gonna starting up again.
Like,
Yeah. It's not a simple story.
I do.
sort of like.
Aya, are you online?
Yes, I am.
Basically.
They don't get to control that, so.
Yeah, she is.
Excellent. All right. Okay, guys, we're gonna get started again just to keep us on track.
At that time, are we?
Guys, we're gonna get ready. So up next, we've got Aya Lalu. She's a PhD student in Pierre Gentine's lab at Columbia University. She's sharing her experiences with agentic based translation of legacy code and generally a translation pipeline. She's been very kind to share her experiences with a lot of groups. She's already talked to the Atmosphere Model Working Group and the Land Model Working Group, but we did save the best for last, the software engineering group. So we're very happy to have her here and look forward to a lot of discussion with her. So ready when you are, Aya. Thank you.
Thank you. Thank you for the great introduction. I did give this presentation a few weeks ago at the Atmospheric Group and the Land Group, but I hope it's not very redundant if you were there. But I'm very excited to have a more in-depth conversation about specifically how I've been using Claude Code for the translation from Fortran to JAX. I am from Columbia University. I work under Pierre Gentine, and over the last few months, I've been trying out new pipelines or ways to translate legacy Fortran code. Specifically, I've tried with the CLM multi-layer canopy model to JAX. And all of this presentation is going to just talk about my experience doing this specifically with the model of Claude Sonnet 4.6. So some of the motivation that really got us started with this project was the want to have modular code, the want to have a model that could be differentiable, and a model that can have a very easy machine learning integration and not have that be a bottleneck when developing a hybrid model, but also have it be accessible and have an increased community engagement, specifically from perhaps grad students or postdocs or even undergrads that are not as familiar with Fortran, but can get started easily on Python or JAX. So I wanted to first talk about agents generally, and as a lot of you have said earlier, a lot of the problems that we run into with agents running code is that the longer it runs or the more that we want to give it tasks or a bigger problem, the worse it gets. So while it tries to do more and more tasks in one session, it tries to compress the context, which ends up actually missing and forgetting some very important key details. And in very big problems with an Earth system model, for example, every key details really, really matters. And so that's a main drawback of single agents here. That also introduces bugs and also forces you to repeat yourself when you don't want them to, bypass your tests or delete specific code that was written already. So I've found in my experience that that's very specific to single agents. And as a alternative, there's also multi-agent systems that a lot of people put in place, specifically in Claude Code. If you are using that, they have two kind of formats of using a multi-agent system. One is called subagents and one is called agent teams, which is very new. But essentially, in multi-agent systems, one agent is delegating to focus specialists within the same session so that each subagents have a very specific context, and they preserve all of that context because they're very specialized. They don't need to remember any of the other context that maybe another part of the code needs to do, or another part of like your agent system needs to do. So this also helps to enforce constraints and by limiting like the tools that a sub-agent can use, or just the actions that it can do. For example, the specific sub-agent should just only write code, not delete code, and so on. So the specialized behavior also helps it be better, perform better at those specific domains, and also control costs. If you know that like one part of like your pipeline will need more, will be like the most complex in translating or giving that task to an LLM, maybe that specific sub-agent should use a model that is more costly, that can handle more complex work, like Opus, which is more costly. But then in other ones, for example, if you want a sub-agent specifically for documentation or specifically for tests, you can allow yourself to run it on like cheaper models like Sonnet, or if it's even as simple as documentation, you can run it on Haiku, which is, I believe, the cheaper model of the three from Claude. And so in general, this setup can improve by a lot like the general output quality that you're desiring. The main difference between sub-agents and agent teams here is that sub-agents do not communicate between each other. They communicate towards the main agent. And so it can become like a bottleneck in certain areas where you want actually, let's say, your tester and your translator to communicate between each other. But if you only want the output out after each step, then you're able to run that. And that can also run in parallel and save you costs because we're using less input tokens generally in context. And then agent teams here like is just a fancier version of the sub-agents system that Claude had, in which each teammate is essentially an agent that can not only talk to the main agent, but also talk to other agents as well. And they kind of share a general task lists that they can divide between each other kind of independently. My work is similar to sub-agents essentially. So I've been setting up this pipeline that takes in these main sub-agents, the translation one, the testing one, and then the repair one. Those are the main agents here. And add to that like specific context that would help our agents or LLM perform better, such as static analysis, which I'll go in a little in more detail later, and then the part where we actually run the tests that were generated. So essentially, here we would take a legacy Fortran code and then generate some information or take in some information about the dependency of the dependencies existing in that Fortran code, and also maybe separate it into specific units that can be fed into the translation agent next. The translation here just does a first run of the Python translation, which is then fed to a testing agent that generates tests as well as testing data if you don't have that. And then we run the tests and have an iterative repair process. If the tests do fail, we can iterate and repair the translation until it passes. And that's where we get our final code. So first, I wanted to talk about like how to set us up for success and set your LLM up for success. In a lot of examples that I've been seeing and that I've done myself, having code that is pre-modularized to some extent and having clean code is really key for the success of this method and like how well the LLM is going to react to like your task list. And then secondly is really having existing test data or tests, which is not very easy to ask from everyone or any like Fortran code based, but it's really important to save inputs and output data from Fortran, like high order subroutines, so that we know exactly like what to compare it to, and limit really the errors and bugs that can be created by an LLM just generating its own test data. So it's just an added validation step or work at first to help in the future. Yeah. And so with the Fortran inputs and outputs, we can change the pipeline slightly to actually input that to the testing agent, not having just generate the test data itself. So I wanted to talk about the static analysis and what like it actually means and can help with. Here, it helps a lot understanding the dependencies that exist in the specific code base that you want to translate, and understand if there are any circular dependencies as well. So in each module, we use FParse and networks like through a specific module in the GitHub that I showed first, to extract for each module which are the dependencies that are used, and so that the LLM has that information later on and can use a smaller context window. It doesn't need to look at the full Fortran code at all times to translate one specific module, but it does only have that information about this module needing these specific dependencies. And then secondly, for the static analysis, we do it to also break large procedures or large modules into like smaller chunks, specifically into like they can decompose them into subroutines if the subroutines themselves are not too large. So this is some data about like the number of attempts to translate a function and getting it to success versus the actual function length. And so the longer a function is, the longer the more tries it actually like takes the LLM to translate. So that's why we do this specific step. And then the way we also use the information that we have about dependencies within a module is to have a dependency ordered translation. Essentially, if we translate in the wrong order and we don't have any information about a specific module, specific dependency that a module uses, it does increase the risk for an LLM to hallucinate. But if we do the translation in a specific order where every dependency is always translated first, then we don't have any undefined references. And with the context accumulation of the LLMs and Claude specifically, the translation units that we see previously are added to the context and cached. So that's we know exactly like what they look like, and this generally reduces LLM errors by about 30%, which is a lot. And then also last step to set us up for success really is to think about the prompts that we are given the LLM and the effective like prompt engineering. Effective prompts can lead to like 3 times better results. And the way we do it in this specific pipeline is really just to have, given the lines of code that we specifically want to translate for a subroutine, give it also the dependencies that we have, and as well as the previously translated code, and very specific requirements as to how to perform the translation. Specifically in this translation that we did to get JAX code that is differentiable, I had to go and in detail write like all the requirements of what that could look like, so that it doesn't just revert to old like Python code, but specifically uses the JAX libraries specifically for loops or continue statements. How should they be changed so that it respects the JAX requirements? Yes, so now talking about each specific agent and this pipeline, the translation agent translates one subroutine at a time or one unit at a time if you're working with something different, and then finally does a last call that is a final module assembly, so puts together all the subroutines together in a module and make sure that everything is consistent. And For example, for the soil temperature module of the CLM, it was translated, or it was separated into 8 translation units, and it was an assembly call. And so in total, the translation for that specific module cost 56 cents. So that gives you a rough estimate of like what the cost could be. And this is with Sonnet 4.6. So the testing agent next, what it does is, if we don't have any legacy unit tests, this is like very important to have a test suite that will be available, not only, that will be useful not only for this specific pipeline and making sure that our translation makes sense, and if we need to repair it again, but it will also be like very useful for future development, and we can specify the targets of like, what kind of testing, what kind of tests we want to generate. And the first try that we did was to generate tests and test data that both together, but this really just led to many bugs and also failing tests, or LLMs just kind of changing the tests so that the code or the translation passes. But with the second try of like having generated tests based on the Fortran subroutine levels of inputs and outputs, it did lead to like much better results and being like very firm on the inputs and outputs being like unchanged, because that's what we're targeting. Finally, the repair agent, when our tests fail, is a very important step. About 45 to 73% is the actual success rate for first pass translation. So about 25 to 55% need repair, and doing an iterative repair process, it also increases accuracy. After only one repair, it increases the success rate to 65 to 85%. After 2 or 3, the success rate really gets up to 80 to 92%. So that's why we chose an iterative process. In my experience, after 3 iterations, it is most likely that it's something that the LLM will not fix by itself, and that's where I usually set up the maximum number of iterations for myself and look into the code and see what is the actual issue. Yeah, and so this is what the end-to-end pipeline looks like for me. I choose the module that I want to translate right here, and then run the full translation workflow. And then the LLM just does the rest of the work. There's very little like interaction that you need to do. So the first step is to run the translation. So that's what the module does. Once it is translated, it does save it and gives you the place where it is saved, and then immediately starts the second step, which is the test generation. So when the test generation starts, then it ends. You can see where the PyTest suite is available. Here you can see for the specific module that generating the PyTest suite was 34 cents, which is quite good. And then for the it runs the test. This is not like an LLM test specifically, but this is just in the workflow that we set up. If the tests failed, which they did here, the repair is called immediately. So yeah, we've got some preliminary results, which, for example, we translated the mixing length module in Club and some other like dependencies of it, and it was quite successful. I haven't looked at it like in a while, but it was differentiable, which was very exciting for us. And the differences between the actual Fortran output and JAX output were very minimal. So that was good to see. And then for the preliminary results of the CLM multi-layer canopy model, we picked that specifically because it was just a great candidate for GPU acceleration, just given that it was 5 to 10 times like more fine resolution than the Big Leaf one. And so it was about like 15,600 Fortran lines. And it was translated to JAX in less than 5 hours, which was really useful and helpful. And then the next steps here are the validation steps. So we're able to run the full CLM multi-layer canopy model altogether, but there are some subroutines or some modules specifically that are failing. And so I'm now like in the process of getting like more of the inputs and outputs from the Fortran code. So running the Fortran model to get some of that data to validate and repair some of my code. Yeah, but this is my summary slide, and I hope it didn't take too much of your time. If you have any questions, please let me know.
Any immediate questions for Aya? Otherwise, we have a discussion after Kate's next talk. But I'm happy to take immediate questions now since Aya's remote too. No? Okay, thanks.
Maybe
again.
just,
Oh, yeah.
have you done any performance comparisons yet? I see the 50x speed up there, but I didn't know if that was what you were seeing yet.
Yeah, that was from the other papers that I cited, specifically like trans agents. I haven't done a performance comparison yet, just because I'm still trying to get exact like numerical parity between the Fortran and the JAX.
Oh, okay. All right. Thanks.
And Daniel Howard has a question online too.
Yeah, so I think in the context of like many of these kind of transitions apps, and thanks for the presentation, is the value add and requirement even. I've heard others communicate about effective testing, software testing that already existing in many of these codes as you're doing these porting processes. What are your thoughts in terms of navigating effective test development or having sufficient tests, and whether that is in fact a requirement towards effective LLM assisted code generation?
Definitely. I think that was a very big bottleneck for us in this translation, is the lack of unit tests available. And I spoke to other labs that did something very similar, and it was the existence of tests was very important in how good or how fast the actual translation process was going to be, for the LLM pipeline. And if not actual existing unit tests, having a thorough input and output like infrastructure of like your code is almost like as helpful, and then you can like build test cases like with your LLM around that. But really having like inputs and outputs from each like high order function or subroutine is very, very important here.
Thank you.
Great. Thanks again, Aya. Okay, we're going to go on to Kate here. So Kate is a scientist here in CGD. She also is a software engineer and now also a project manager, because she's very talented, and she's been working with the team in ACOM and CGD via the CSF that's doing some modular chemistry and aerosols, and is going to talk briefly about some of the work they've been doing with AI. Yeah. Oh, and we're going to share. Oh, no, sorry. Yeah.
Did I just turn that?
Well, give us a second. Yeah. Oh, I don't think you're in the, you might not be in the session.
Sure.
Oh, let's see. Yeah.
I thought this one would just be, it's like it was set up. There it is.
There we go.
Thanks.
Awesome.
Thanks. All right, yeah, I think I asked for 5 minutes here just because this isn't exactly my work. So I've been working with Kyle Shores and ACOM on the Musica project, and I thought he would be a really interesting person to talk about this because he's a big C++ C booster. One of his big arguments is that C and C++ has wider community adoption, and so it has more tools and more support available than Fortran legacy code. So my question for him was sort of along the lines of, do AI agents do a better job with C++ code than Fortran code or other languages that are maybe more commonly used? Or just, some information on your experience working across multiple languages, because Musica library also has JavaScript interfaces and a lot of different language support. And he was out of town, so I couldn't give the talk, and he sent me a quick email with some PRs, and I put this together. So this isn't going to be a very good answer to those questions, but it's where we're at right now. My basic overview here. I also wanted to say that a lot of these talks I give for software engineering related topics don't have a lot of pictures. So I have to get creative. And in this case, I decided to make show pictures of snow in Colorado previously. Just try to get it to snow again, to remind the atmosphere that it's possible. So you guys are going to see snowy pictures, and hopefully that will help with the local pattern change. So Kyle's notes, positive uses, he said that, a bit of a mixed bag. He's been generally using Copilot and Claude to do work in Fortran, C, C++, Julia, JavaScript, and documentation and Markdown. He said there's some tasks where we can do all the work with only minor changes, and they tend to be small and focused without ambiguity. So here's 3 pull requests that they've approved and merged that were done entirely by the robots. And you can see that like reorganizing readmes, even though it does, impact multiple languages, this is a pretty specific Markdown only code refactoring, and it went really quickly. Adding Julia to the CI workflow, there was one small commit from Kyle to sort of adjust things after the robot was done. And it's kind of nice because this PR in particular includes the original prompt. So you can see exactly what was used to sort of get this to go, but it wasn't a lot of code and it went well. This last one, the exposed solver parameters through all the language bindings. So this one was Fortran, JavaScript, C++ code header files. And the language models actually put all of this code in a single commit. And then you can see in the conversation, Claude is reviewing its own PR, and I thought that was kind of fun. It gave itself 15 comments and then fixed those itself. So that's pretty nice. There's a little bit of, I guess, Kyle line of code changes at the end, and then went ahead and finished it. So that's kind of one of those like scary, easy things. Like you just sort of said, do this thing, and the robot does it, and you're like, why am I here? Little having an existential crisis this morning. But of course, there's, certainly times, and again, this follows the theme of like bigger problems it has trouble with. But some of these aren't necessarily bigger problems. They just sort of get off course and lose the context. So refactoring conditions here, this PR hasn't been merged yet. You can see it's still in review and it's spinning up other issues. I think the problem became bigger than they realized. So it started work with the robot, and then as the humans were reviewing and looking through, they realized that this is just way more complicated than one PR. So that's, you're learning something. Maybe some work was done by the robots, but not necessarily all of it. This particular PR, so in the description, it actually says much of this is written with Claude and Copilot, though much had to be corrected by hand still. And there's a lot of commits. If you read through them, it's really entertaining. And Kyle saying like, correct the NVIDIA Docker file, correct the map type, correct the MICM conditions correction. So like, it's just still required a lot of hand work at the end of that. And then this one just kind of went completely off the rails. So just adding initial Julia wrapper. It was supposed to be a very small thing. Add a minimal Julia package that exposes this get version function call. So all it's supposed to do is return the version for Musica through the Julia interface. And you can see the comments in the PR is Copilot, there's a build error. Copilot, everything built, but tests don't pass. Copilot, the library still cannot be found. So for whatever reason, I'm not sure if it's the language or something in the context at that point, it just was not working. So yeah, there's definitely some good stuff, there's some bad stuff, but we're using it more and more right now. And I think we're going to keep hitting this. I think that information from today was very useful. I wanted to add in a few more things that I've seen. I'm not sure how much of this I should exactly be talking about. So David Fillmore is another SE in ACOM. Victor Weeks is an SE in RAL, and they're both working with MCAS on ACOM related work, bringing in Musica and emissions. And both of them have talked about using the multi-agent setup that Aya was just talking about. So I find this workflow very interesting. David was talking about 3 competing and antagonistic agents that were competing with each other to write the best code. I'm not sure that David heard your talk this morning about how carbon intensive that is, but he felt that that was really producing better code. Victor was using 3 agents on the emissions code and Impasse. He has an architect, a tester, and a developer, so agents with specific roles, and that's more like what Aya was just talking about here. And they work together and have implemented the feature. But we haven't integrated or tested it yet, so that's still very, very early days. I just want to toss in a few of my experiences. Last summer, I had a CI Compass intern named Tamara Siegel, who worked with Claude to convert a tool that we were using that was written in Bash and Fortran and MCL
into Python totally. So this is a topography updater for the ice sheets to translate the topography changes in the ice sheet to the lower level of the atmosphere. And it's been a bane of my existence for a long time. So she had the best luck role playing with Claude, and she used prompts like, pretend you are an extremely skilled software engineer with expertise in converting scripts from one programming language to another. And in the end, she did get something that compiled and completed the task without errors. We haven't gone in to double check if it's done like absolutely correctly yet, but it's a place to start. And I'm actually going to be revisiting that over the next couple of weeks. So I'm going to be sitting here and email it back. I felt kind of bad. She came to CI Compass at NCAR with a strong desire to like make the world a better place. And I gave her this AI project, and her presentation had like 2 slides at the end of it about how much carbon this summer project had produced and how bad she felt about it. So it is definitely something to keep in mind. And then just recently, I've been sort of working with Claude a little bit. This is my husband in the snow. And we have a very big PR for SISM that is, I spent a whole day, 8 hours specifically reading through all this. And I didn't even get into everything because there's thousands of lines of code changes that my coworker did. Then after all of that, I had some things that I wanted him to work on, and I'd come back and finish the review later. And out of curiosity, I asked Claude just to like review this PR and see what it would do. And it came up with 5 suggestions that were actually very similar to mine. So I felt better about myself. I'm not sure if that was like a great usage of but it was really fast, you know? So like instead of 8 hours, maybe I could have just started there, asked him to change those things, and then gone through it more fine-tuned on my own later. But even after all of that, we're getting runtime errors. And I was telling Bill Sachs this morning, I tried just asking Claude, like, could it fix this bug? And it did suggest, like, even in this massively parallel ice sheet model entirely written in esoteric Fortran, a missing Halo update, which is a very specific high performance computing problem. So I was pretty impressed with that, and I plugged it in, and it didn't fix the problem. But, you know, maybe there's other places. So we're going to probably revisit that. I have to decide if I want to spend the time debugging it or if I want to spend the time working with LLMs to try to see if they can figure it out. So in summary, I hope it's good. That's where we're at. Thank you.
All right, everybody, we have some time for discussion and general questions now. I think, again, I want to start by deferring to people online if there are questions online, simply because those of us here can also continue conversations at lunch and whatnot. So, yeah, questions online. Yeah, yeah.
Yay, David.
Hi, Kate.
Yay. Oh, so glad.
Yeah, I just want to get comments. So I'm spending time also what I call cross-model reviews and validation, where I do something in Claude and then I have Codex, just a different LLM, review it, and then Claude reviews, you know, just a lot of cross-model, I'd say. I don't know if other people are looking at that. Is it worthwhile? Or is it, I've found it somewhat worthwhile, and I'm just curious thoughts on that.
I think that everybody is, or a lot of us, I think, are still just kind of dipping our toes into this. And so I think what might be nice, David, maybe what I'll do is CSEG, the CSM Software Engineering Group, is starting to try to have a little segment on SE AI best practices. And so maybe we'll have you talk a little bit more about that there, and we can discuss it. I think people just need to learn, like that's kind of the goal of the hackathon too, is just get people familiar. But I don't think anybody has, like I know Dave would love us to have a best practices document. I think we're a little ways off from that. But yeah, I think all ideas are good at this point. Bearing in mind the cost of the carbon and yeah.
Yes.
Rob.
Yeah, hey, I was wondering, I wanted to ask John Dennis if did he say his experience with Copilot was several months ago?
It was a while ago.
Okay. Yeah.
And I have not, I was not encouraged by the results, so I've not gone back to it.
Okay. I think it's gotten better, but your mileage may vary on a lot of these things. I think. Yeah.
But which Copilot were we talking about? Didn't you say like GitHub Copilot?
It was GitHub Copilot.
It sounds like that's what
And that's
we're
like
talking about.
different than like VS Code Copilot and VS Code.
Correct.
Yeah.
Too, right? So
Where
there's
it can-
differences.
Like I think it probably would have been more efficient for the stories you were telling about those PRs if it were actually running in a situation where it can run the test itself, right? That would have reduced a lot of the human back and forth.
And I think from Rob, you could clarify, I believe you said the other day that the DOE is now adopting this for some of the repos, right? But I don't know the details of this. Yeah. So
Yeah,
you
well,
guys-
no, E3SM decided to buy Copilot seats for people who want them.
Got it.
It's $19 a month. Because it's so integrated into GitHub. And and mostly we use it to review PRs, an additional review on a PR, and it's usually finds something useful. You can just click in the assignee menu, you can just assign Copilot in the menu and it'll go off and review it. That's kind of useful.
And we've used that as Copilot as reviews as well. They generally found kind of pedantic stuff.
Yes.
Other kind of, yeah.
So what I'm hearing from this from Rob is that, Rob, you're going to give a summer software engineering working group talk about the experiences DOE has with this, right?
Sure. Yeah, I could do that.
Hey, awesome. All right, there we go. All right. Other comments, questions? I'll open it up to the room here. Yeah. Okay. So I don't know who's first. Yeah.
If you have something. Well, I was just gonna offer a suggestion, since this is more of an open discussion. I don't think we've spent enough time on answering stupid questions. There, like a month ago, I knew none of the stuff I just presented. And like people, like I didn't even know like the difference between Claude and Claude Code. Like Claude Code is not AI. That's just an interface to a large language model and whatever agents they have running in the cloud. Just stuff like that. Like, and I wanted to encourage people in the room and online, like ask what you think are stupid questions, because I was stupid a month ago. We'll all be a lot less stupid if you ask what you think is a stupid question.
And I'll build on that and say, I think one of the things that I'd also love to hear from people is, again, we've taken the perspective of, this is a big area. Everybody has different jobs, different responsibilities, different levels of experience. We just wanted to start with building some familiarity, but now the question is, well, where do we go from here? And maybe that is laying out the so-called stupid questions. I don't like there being any stupid questions, but
I meant to say,
like
those are things.
familiarizing people. But yeah, what would be next? Like we've talked, some of the people here know we're trying to do a larger evaluation now of Claude Code and other things, but I'm happy to hear ideas of what would be helpful for this community.
Eric has a question.
Oh, Eric.
I have a stupid question. I'm learning about, like Aya especially talked about this, about the different agents. And that's, I know how to, chat with Copilot or whatever, LLM as a single thing. So how do you set up different agents?
This is a great question. Maybe something we should do in a hackathon bit. I know, actually, this is where we assemble a document with some resources. Because I know Mom6 recently set up like a Claude.mb file that is giving some guidance, and there's all these other things rather than just talking to it. There's a lot to learn here. I don't have a ton of experience with setting up adversarial agents, so that'd be great to learn from. Again, this sounds like a good direction to move in, is to get some of these more hands-on, here's how you do this, as people build familiarity. Yeah, David.
I just want to add, so there are also really agentic workflows in development, depending on, you may not be doing a lot of having the agents actually do the coding, but Claude can build your code, like literally clone a GitHub repo, point Claude to it and tell it to build the repo. It'll figure it out. It can run it, so you have skills. Here's how to run, modify your config files. In my workflow, I have sub-agents spawn, so once my ChemPass model starts running, they can start scanning the log files. Sub-agents do this. They can start reading netcdf. They have commands, right? So we'll run launches, and you have all these agents facilitating your debug cycle there. So there's a lot that these can really do that are really useful beyond just, write me a script and things. So I'd love to hear, how other people, and I do everything interactive sessions. So this isn't like the structured API with some of our talks, right? It's all just, so I'd love to see if other people are setting up these more extensive workflows and things like that.
Yeah, I think I'll start a collection of these. Jim just put one in the chat. This is the SEAM, the infrastructure we share with DOE and CSM, and he set up, put the agents that are they're setting up there in the chat. So take a look at the PR, you can look at the files, and that's some good ideas. But we should start a collection of these and moving towards best practices, which again will make Dave Lawrence happy. So yeah, Bill.
Yeah, I guess this is largely a question for David and Aya, if Aya is still there, but also more just generally. You know, and you both talked and presented really interesting things about kind of an iterative workflow and having these agents kind of do a repair cycle on code and kind of iterating, as I understood it, iterating until kind of the tests pass, which seems like that sounds like the really like efficient way to get kind of an automated workflow that takes a human out of the loop as much as possible. At the same time, it kind of makes me think about like experiences I have working with code that I know has been written in a kind of trial and error process. And I know like code written by a human in that way, like often you end up with code that looks right and passes the tests, but has subtle issues either with bugs that aren't covered by the test suite because it's impossible to get 100% test coverage, or maintainability issues. And so I'm curious about your experience seeing the code that evolves from that workflow. Should I be worried about these kinds of issues, or does it work out better than I might be afraid of?
Well, I guess I'll go first. Maybe I is still around. I don't think that it's sort of like self-driving cars, right? Like, what do you think about self-driving cars? Do they have to be zero accidents or just a lot safer than humans somehow, right? So it's kind of the same thing. Like if it's similar to what humans produce sometimes, and it gives you things that are like not covered with the tests, like did it save you a lot of your development time to focus on the hard problems? So that's kind of like, so, but what I've seen, yeah, the code looks reasonable. It's basically we're trading on the internet, right? So whatever stack you would have gone in the old days, you would have gone to Stack Overflow and you would have said, how do I do this? I don't know how to program Python, right? And now we ask the LLM to write me a Python script. Well, it's writing the Python script of the quality that it learned on Stack Overflow, right? So that's kind of what it's giving you, you know. So if you think you're so much better than the internet, then you're better. But if you think, hey, I pretty much use the internet, then you're probably about on par, right? So
I've got follow up, but I might let Sam.
Well, so there are a couple of subtleties there. One is that a human often, well, I'll speak for myself as a human. A lot of the time, I will realize something in the process of writing my own tests or writing my own function or whatever that I wouldn't realize if I were just looking at reviewing someone else's code, right? And so you do use that step. To some extent, an LLM might be better than me at realizing that while it's writing it, right? So like that's kind of hard to say what the difference there is. I forgot my other point, so we can go.
The speed at which you can produce code, though, so that's true. You do miss that human of like catching it, but you're not. You know, that LLM might write more covering tests because you're like, okay, I wrote a test that took me 2 hours. I mean, the LLM can just spit out lots of tests, right? And we don't want to bloat our code, but if it made 20 tests in a folder, that's okay.
Absolutely.
It makes a lot more testing, so maybe it's giving you better test coverage.
But I remember my other point, which is that your question about maintainability. At least with the workflow I've been working with, I often need an extra step after it's already written its thing for me to say, there's a lot of code duplication here. Can we reduce that? You wrote 20 tests. That could just be one test using PyTest parameterize function. Can you just go ahead and do that for me?
Would you tell it that? So that's one thing I want to mention when we talk about agentic versus LLM models. I think that's a dumb question I had a few months ago or a year ago. What's an agent versus what's a model? You know, when you pay something to ChatGPT, you're just asking the model and you're saying, please write me a function that does this, right? And now the agent is more on top of that, right? The agent can decide what's the right question to ask the model underneath, or how do I break up this question into something useful, and how do I even create my secret agents that you don't even know about that are both competing to give the better answer? So all that's happening under the hood for you, or for us, agentic AI for us is doing the whole Fortran code. That's sort of the agent we're building, and it's built out of model calls, but like what's each part of it, and how do you decide how to break up the problem? That's this agentic or agent format. So again, like that agent might do a lot. Like you're functioning as an agent when you say you should have made the code better. Now please do it. And that's fine, but you could maybe think about that should have been removed from the loop. You should do your rewriting version, then you should have another step that's automatically part of the prompt in the agent that says now clean up your code. That's the last step.
Yeah, I guess, and I totally hear your point on like, on, you know, the analogy with the self-driving cars. I mean, I think self-driving cars are great for everyone except for myself. I want everyone else to be, all the other drivers to have self-driving cars, and I'll still maintain my own control, but whatever. But I guess to like clarify my just question or concern, I don't know whether to say it's more of a question or concern, but like, I think there's, you know, there's different coding processes that people use. And so when I see a process that's set up that is more that kind of trial and error process, which is a process that I know in my experience with like human coders doesn't produce good code often. That applied to, so it's like, how much should I expect the code that comes out to be code that's similar to people following that process versus people following a process that's like, let me understand the code and then produce code.
Well, we did this with Lano. Lano was very much like, we have a certain set of guidelines of how we want it formatted, how we want things done. You declare stuff at the top, you know, style guides. And so if you brought in a new engineer, you'd say like, hey, you need to like contribute to this project in this way. And now you can provide those as context of here is a guide file, style guide. When you're rewriting this code, you do it in this manner. We want it, you know, to do C++20 in this way. And so we're providing this as like skills, and you can add skills to agents too. They're like, here's how we want you to write code. So I think what you're talking about is a lot of one grad student came in and a different one came in years later and they write different, you know, different styles and stuff. And then the code gets very like different. But,
Well, haven't we heard from Aya yet?
Aya had to drop, I think. Yeah.
Oh, that's why we.
Oh, shoot.
I didn't want to be talking.
Yeah.
Okay.
I've been talking a lot. David?
So I just want to mention in terms of best practices, in terms of interactive sessions, Claude and Codex, they have formal planning modes. So the more time you spend in planning, very careful plan, the more time you invest there, the better your resulting generated code will be. I've really found that makes a huge difference. And so you do go into a planning mode where it's going to step you through what it's going to try to do. It will ask you questions. You can say, no, don't do it like that. Do it like this. So that's a big help I've found.
Yeah, that's what I was going to say too. Like even in VS Code, I can just put it in ask mode and I say, give me 2 or 3 strategies for how you would accomplish this task. Mm-hmm. And the fact that it thinks through those different options gives it the pre-context for when you say, all right, you're in agent mode now. I like option 2 the best. Go ahead and do that. And that will get.
They'll write the plan out. So just between sessions, right? You stop a session and you pick it up and say, where are we in the plan? You know, what's next to do, kind of thing. So.
Mm-hmm. And I'd say these are all things we can try during the hackathons tomorrow. So it's good chance to experiment with this. Any other questions? I was happy to eat into the break because it was a short break. I don't want to eat into people's lunches. So we're already 9 minutes over.
I'm just really interested in this kind of dynamic code rewrite cycle, because as much as probably a lot of us in the room hate it, it's probably how it's going to work in the next few years. Our community has always been very focused on the bit reproducibility of our models, which is kind of different from a lot of scientific fields. I feel like maybe this might be a unique strength for us in order to create the kind of tests that will verify these things, because otherwise we're sort of stuck either running very long simulations or forced to sort of find tolerances that are difficult to define. I guess I'm throwing it out there to almost just a reaction. Like, do people think that like, if we could strengthen the bit reproducibility of our models, that would actually accelerate this process of the code rewrites?
But I mean, why is 1 order of bits correct.
It's not about
Uh,
correctness.
I
It's
mean-
just that we have something that we know works in one thing.
Well, I think you need to relax it. I mean, just because you reordered the summation order doesn't mean it's wrong.
Oh, I want to be clear.
It-
I'm not
You
saying,
can take a more sophisticated statistical approach to that.
oh, I agree with you. And I'm not insisting that we focus on that. I'm really just asking, do you think the bit reproducibility-ness of a code makes it possible to do these rewrites much more quickly or not?
I think I'm in John's camp where I think it hurts them.
So-
Okay, okay.
I agree.
Yeah, I just. I
But in
would
that case,
say-
how would you define the tests to do it?
So this is a little bit off the topic, but similar. So, one of the things that we're doing as part of the modernization of our models right now is, adding in the CCPP interfaces, completely refactoring a lot of the way the physics are working, and in some ways actually adding in new and better physics in some ways. So, like when it comes to this modularized chemistry, it will not be bit for bit reproducible. And, maybe that's okay if we can show that it has the same scientific functionality, but it's actually better in a lot of other engineered ways. So I do see the value of bit for bit reproducibility, especially when it comes to like, I need you to do this task and I want it to be very traceable and understandable and clear. But I think that when it comes to modernization of these models, that we do need to be a little bit more relaxed about like what we're doing in some ways.
Yeah, and I want to be clear, I'm not making a judgment on the scientific value or even, any of that. I'm really just asking about the fact that these agents are going to run so fast and just generate stuff so at such an accelerated rate that they're going to be writing hundreds and hundreds of tests, that whether or not we need it to be kind of well-defined, if we need the output well-defined in order to do that one-to-one mapping of code.
And what I'm going to say is, maybe this is a good conversation to continue at lunch. I don't want to keep people. Everyone will be back here at 1:15 for the other session. And yeah,
Sorry, before we leave.
Yeah,
can we talk about the afternoon hackathon situation? I will be presenting if anyone joins me, but I need like a screen to present at. So I'm calling dibs on the library location. I don't know which link that corresponds to. So
I think you'll be able to type in the link that's tied to your hackathon, but like on the box, you should be able to enter a specific meeting and get in there.
Okay, yeah. Then I will see anyone interested in the library. If no one comes,
that's tomorrow, right? Tomorrow.
No, I'll be here for the afternoon.
Yeah,
I'll be here.
tomorrow.
Yeah.
The afternoons are talks though, right?
Yeah, but I'm not going.
Yeah.
I'm sorry, no offense, but I didn't realize that hackathon was also going to be in the afternoon, so I made other plans for this afternoon. So I won't be coming to talks. But I will be there for an hour unless no one shows up by 1:30, in which case I'm just gone.
Okay, cool. Thanks, everybody. Go have lunch. See you soon.